I've heard that a few times in headlines. Sure you didn't just read the headline?
Nah, I saw a couple of videos on it. This kid, they're saying he invented a free energy. Put it this way, they're saying he's the next Tesla. This young kid, he's 21 years old now. But I was just wondering if you guys heard, because he says that they opened a porthole to another world, kind of like what's that show called?
Teenage Mutant Ninja Turtles.
No, bro.
Dimension X.
No.
Dimension X.
Seriously? What do we call
That Stranger Things, something like that.
Stargate? Oh yeah, I'm about to watch the new episode right now of the new season, dude.
Like, you know the details at sea or what?
Well, the details are that he claims that they opened the porthole and it caused some weird effects, some strange clouds, and devices started going strange and this and that. But CERN says it was just a glitch. So there's not really much details on it more than that.
They say that if something existed in the fourth dimension, we would perceive it as being like a cloud. I think they called it something similar to a cloud. But yeah.
And then you have that Indian.
I was gonna ask. So the kid came out saying that, and then CERN came out saying like, nah, it was just some malfunction.
Yeah, exactly. And they're saying this kid built a free energy device, which of course they discredit it, blah blah blah. And they're saying he's like the next Tesla. That's what they're saying about this kid.
Well,
Is it the little blonde-haired kid
saying
with
that though?
I think he's blue eyes or whatever?
Yeah, I posted him. His live text stream 1. I posted a thing on him.
Oh, let me look. Because I've seen him before if it's the same kid.
Yeah, it's a blonde-haired kid, yeah.
Yeah, that kid. Yeah.
No, I brought it up because I heard you guys talking about CERN, and I was wondering if you heard about that.
I don't know, man. I'm skeptical of their findings.
Joe Rogan, come on, man.
I was waiting for somebody to say that, but he did interviews with a whole bunch. Yeah. Look, I don't believe a word of it, right? I don't believe CERN. You heard me talk about them smashing particles and squiggly lines and that. But since you brought it up, another thing. Apparently where it's in an old Roman site of God of the Dead or some, all these stories are swirling around. And then you have the Sheba statue outside of CERN, and then their official logo. I don't know if you guys know, it's 3 6s. You ever seen that? So there's that.
Yep.
Yeah, but this one trail, like where Dyslo started, you said Crooks, then CRT2, and we end up at CERN, right? But then there's one guy, man, I'm telling you, in the middle there, they deleted Philo Farnsworth, the tangent to the guy that, according to Dollard, he's the only man that understood what an electron is, supposedly, because he's the one that gave us all electronic television. But then he went on to develop this all-electronic fuser. It was about fusion. He can do what Rivermore Laboratories, National Ignition Laboratory, with their standing fireball, big plasma fireball, and the giant magnetic confinement, right? He did it without that. He did it electronically. So in a small desktop apparatus. So yeah, anyways, his story gets deleted out of the history, essentially. And he doesn't make a penny off of television, even though he invented
What did he say the item was? Because Dollard is no slouch.
Oh yeah, Dollard said Philo Farnsworth III, he's the only man that understood what the electron is, right? Way beyond J.J. Thomson and these guys. And Dollard said he wrote no books and he's dead. So here we are. You know what I'm saying?
Do we know what he said it was? Do we know what he said the electron was?
JJ subscriber, the end of the Faraday tube. That's it. Because Dollard had access to Philo's notebooks because he met his grandson in California or whatnot. So he actually he read his notebooks, his own notebooks that nobody has access to. The Farnsworth family has them in their library. So for sure, what the subscription is, it's the end of the Faraday tube. One is an electron, one is a proton. The termination points of this the filament, right? The dielectric filament, if you want to call it that. Faraday tube. Give credit to Faraday and JJ, of course. Because like the perception, because electron flow in the wire is legit, but it's the perception of electron flow according to JJ, because it's the Faraday tubes. As you move this fabric across, bound between the conductors, the electromagnetic flux, right? This XY fabric, magnetic and dielectric fabric. As it moves, rushes down the circuit, it scratches against the wires, the reflectors, as Oliver Heaviside states, right? A perfect conductor is a perfect obstructor, he calls it, and it must be capable of reflection. And you'll notice all conductors are capable of reflection, like metallic, because you must reflect this fabric, this electromagnetic fabric, in this geometric configuration, and only then it'll work, because it destroys it. According to that's different electromagnetic theory shit with Oliver, but anyways, this fabric, as it moves down the grid or the circuit, it scratches against the wire, so you get that appearance of electrons moving in the wire. Notice the fabric scratching the wire and causes the heating effect too. You see, it's this interesting stuff. But they delete that bit. They believe in electron flow, but they don't believe it's tethered to anything in between. The only difference, these guys absolutely subscribe. There's a tethering in between. And all like the work inside of the CRT is essentially on that. You're pulling tension between these two metallic plates, and at some point it gives, right? And if you got low enough pressures, right, this thing now can fly unobstructed. But if you have a little bit of air, it gets destroyed pretty dang quick. This electron beam, but you get this absolute beam, and if you shoot it through like a thin, if the end of your CRT tube is really thin glass that can hold still vacuum, you can actually shoot the electron in air, and you'll see it glow in air before it gets distinguished, like a few millimeters post the window. So definitely something shoots out, but the idea, it's a piece of the metal that you ripped out. The electron in the metal from the plate that you pulled it out of. So
Interesting.
That's the electronic subscription there. That's why vacuum tubes, you'll see in their nomenclature, they always have tron at the end, right? Because they used to be called electron tubes. So you got the klystrons, the cyclotrons, the thistrons, all these. Magnetron in your microwave oven. Everybody's got if you have a microwave oven, you have a vacuum tube device in your house, right? There's a vacuum tube inside, surrounded by the magnetic magnetron, but inside there's a vacuum tube to initiate the electronic emission, which is a CRT tube, cathode ray. So this cathode ray, high tension, you let loose of stuff from the metal, and with the magnetron and the magnetron cavities, we get it to resonate at 2.4 gigahertz, and it just amplifies for some reason. This is where it's beyond my understanding. No, it's if you look into the magnetron. I'm sorry, go ahead. Or the electron.
No, I was wondering, is it like Einstein when he got the prize where he figured out that something comes off of the metal? Is that what you're saying? Kind of like that?
There was no fuck Einstein. It was the person that theorized that was Alessandro Volta with his voltaic pile versus Luigi Galvani. Galvani said it was animal electricity. Volta theorized that different metals, especially metals with different colors, have dissimilar atmospheres around them. which is an electron cloud now in modern terminology, but his terminology you'll read, they have a dissimilar atmosphere, and when conveyed in a caustic bath, whether acidic or alkaline, and you short the plates out, you get something called fire. That's what they called it. With the voltaic pile, it produces fire, aka plasma, the electronic arc. But his theory was you're conveying this atmosphere from this dissimilar metals, and you look today in how a battery works, it'll tell you electron in the metals. And you ask them, where's the electron? You look at the atom, it's a cloud around the atom. It's an atmosphere. So Alessandro Volta is the man who theorized this, not Einstein. Fuck Einstein. You can read it way before. Dude.
Yeah. I'm saying he got a Nobel Prize for that, though, right?
There was photoelectric effect. That's what he got the Nobel Prize for. Yeah. But anyways, pre-Einstein. The whole there's a cloud of, we don't know exactly what, and you can call it an electrical atmosphere around everything, specifically dissimilar metals. You can measure this dissimilar atmosphere. Well, we have electricity from there. It's voltaic pile, the DC battery, and we get the telegraph, and well, all the William Crookes and all these guys were using batteries for their experiments. So yeah, it was essential. And it was not animal electricity. His theory was the one. But we didn't exactly understand what's going on with the metals. But today we say the same thing. Electrons move. This electron cloud. But now we're just looking at the metal, what's happening around the surface. But then with JJ, he got a Nobel Prize for the electron. His idea is the Faraday tubes. Electrons, there's no electron by itself. Electron is connected to a proton in your circuit. It's the end of the dielectric line of force. One is electron, the other one is proton. One negative, one positive. Socket unplug. It's JJ. If you stick with that, you work outside of the mainstream parameters. There's no electrons in your batteries and whatnot. Who cares? It's in the molecular stuff of the metal. You can neglect that. Just deal with the circuit. Deal with the voltage, the amps, and stuff like that. And if you're dealing with electron tubes, you know what I'm saying? You still don't have to worry about how the electron works. You just need to know at what voltage and at what vacuums. Now you have an electron ray, right? Your cathode ray formation. And at what voltage you get X-rays. And it's just voltage tension. So this is something else happens. This is interesting. Between these two metallic plates in a vacuum, see, all you're doing is pulling DC tension between, which is voltage, with no current yet. When the electron breaks, then you'll get current flow registering on the meter, but you're just going to bump up the voltage until you get this breakdown. Okay, and you're going to pull the deepest vacuum you can. Cool. If you accelerate the electron, when you rip it out the metal, right, from the cathode towards the anode, if you do this fast enough, and it's determined by voltage, the voltage is the acceleration of the electron will be measured by how many volts essentially you're pulling between the plates at a given vacuum, right? Because air really does destroy the stuff pretty dang quick, so you want to get rid of this as much air as possible. So when you rip the electron past 30 kilovolts, speed or tension between the plates, when it hits the other plate, they say it breaks and it produces X-ray. But the phenomena of X-ray is legit, and this is where X-rays get discovered from the cathode ray tube again, early on with Röntgen or whatever the German dude. X for unknown ray, right? Because there was this ray that was bypassing physical things, right? And lighting up the phosphor plate on the wall or something. Yeah.
Tesla did that in 18
Tesla did it too.
Yeah.
Right. But they don't give him credit for it.
They call it a Röntgen ray, something like that, if I'm not mistaken.
Mm-hmm. Mm-hmm.
Hello,
Correct.
testing.
An unknown ray.
Okay,
Oh,
if
there's
you guys
pictures
can
of
hear
it.
me.
Tesla was. Yeah, go ahead, bro.
Okay, good. You can hear me. I was trying to speak up earlier, and I had to click out and back in. So you probably went ahead and went over it. You're speaking of Luigi Galvani and him bringing these different minerals that had a differential in close proximity to these. How's the story go? Dead frogs, I believe, and they started kicking and jumping. Did you bring that up?
No, I didn't
No,
go
but
into
I know
depth with
exactly what you're
Mr.
talking
Galvani
about.
yet.
Okay. Well, anyway, I was following along with what you're saying, and I just want to say that you're on the right track for sure. This is what I've found. And like when we have the Van der Graaf generator, Van der Graaf, however you say that, the charge goes um, uh, across what we call the insulator, right? The rubber the rollers where the rubber transfers the charge. And, anyway, we have all this around us that's, like you brought up the perfect reflector, right? The reflector. And these are terms and phrases that go across just electric. They go to light, they go to sound, they go, so, they're all different, they have different properties and qualities, but they're all different, what I call modalities of the medium. In other words, what's introduced the medium, because whatever it be, energy, what we call electricity, which is magnetodielectric, and we have the, well, anyway, each one of them has their own properties and qualities, but they take on the qualities and properties of the medium they are propagating as well. So, like when, say, someone says C, right? The agreed upon speed of light. Well, that is a variable depending on the medium through which it's, and it's been shown and demonstrated. And what I'm saying is common knowledge, but the recognition of the relationships of them all, what we say, follows the path of least resistance, whether it be a water stream or happiness or love. But it's also can be phrased the path of most admittance, and which is the equal opposite or equal I forgot the word, but anyway,
Those are AC admittance and reluctance.
yes,
Yeah.
yes,
Alternating. Yes, of course.
yes.
Alternating
Well,
terminology. AC, right?
especially, yeah. Well, it helps with the more intricate AC circuits, the AC control circuits, especially. It really comes in handy with Siemens or Mohs, what a lot of people call Mohs, but it's yeah, the equal opposite. And anyway, like recognizing there's way more going on than what is physical. Like the originators, like J.J. Thompson, I think he's the one that coined the term electron, said it's not a physical thing, it's a unit of measure. And anyway, the materialists, particularists, or whatever, have a different view on it. And like you were brought up, heavy side, he took and translated basically quaternion arithmetic, which Maxwell's equations are presented in, and to vector calculus under the guise that it was too difficult and complicated for the average electrical engineer to be able to comprehend and recognize and use. And that's just baloney. Like today, now we use quaternion arithmetic or algebra, or however you want to word it, is used in graphics engines, graphics cards are, they're using it, and it's way more accurate, and fast and everything. It seems like it should be brought back to us, because it was taught in the prestigious learning facilities. It was, recognized for Royal Society, etc. But yeah, going back, there's definitely stuff to find and learn. Sorry about my rant.
Yeah, Because if you just turn that, we know what electricity is. It's the flow of electrons in the wire. We're done. Conversation is over. Tell me why you can't jump out the environment. Huh?
You're
My
breaking up.
tire is not spilling electrons. Oh, it doesn't work that way.
You're roboting, Cyrus. The electrons are not flowing.
Yeah, I had
Yeah.
access to my granddad's book. It showed the current flow and electron flow, and they're totally the opposite or whatever. And then I started recognizing for myself, I'm starting to see what I call transfer of potential. That it's not just a one directional discharge per se. And the units we use, joules or British thermal units. It's potential energy directly related with what we call heat. I didn't mean to kill the convo. It's just I've been listening for quite a while, and I just had to reconnect. But please continue. I didn't mean to kill it.
I mean, if
This
this needs
convo is above
reviving,
most.
we can either do SE with missiles or me with East. How do you want it?
Neither one of us, bro. Neither one of us. Something else.
I'm telling you, there's been a huge breakthrough in this East thing, but you guys aren't excited as I am. So
I'm kidding. Go for it, bro. This is the time. It's quiet. What you got?
I don't know. I need someone that was disagreeing with me yesterday.
Well, you got left lane. Who else? You got was Dice Low? Dice Low was disagreeing with you.
I can pretend to disagree.
There, you got a pretender.
Yeah, why not? I've never debated anyone in here. Not that I'm aware of.
This ain't gonna be a good. You need.
I talk too slow. Never mind.
You gotta see with miss. You gotta start with like SC with missiles or something easy, and work your way up to me.
All right, SC, what you got, man?
They can't handle the missiles.
Ah, such a pussy, delicate little flower, aren't I?
No, not you. They go berserks every time we talk. We end up going to China and Russia, and they go berserks.
I was
the
gonna
proof.
try to pretend
I posted my proof right here. All right.
Okay, hold on.
You're at A. You're at point A. Okay. We're standing at point A on Earth. All right. You guys with me? This is easy. East is going to be like the compass is going to be pointing towards B. Like that is the direction of east when we're standing at A. Because that is a line that's not turning left or right. The direction of east isn't turning left or right when we're just standing at A. It's just east. Whatever is that B point, that's east. All right.
That's east.
You guys with me? You guys with me so far?
Yeah, it's weird. So what is this, like the prime meridian in east is to my left? Because I'm conventional usually east being to my right.
I know.
You beat
Flip
me
your phone
to it.
upside down.
First mistake.
Hold on, let me flip it. All right, thank you. Let me flip it. I'm flipping it. I'm flipping it. Okay, now I'm on top of the ball.
You messed up from the get-go, Jeremy. Right away, you messed
Oh
up.
my God. Okay, it's west. It's west. B is west. It works for west
Okay,
or
B
east. It
is
doesn't matter.
west. Okay,
All
B
right,
is
you guys
west.
happy? I knew this was going to be an issue. I didn't think it was going to be an issue this soon, but I figured
Well,
that
dude,
might be
I'm
an
doing a
issue, but
good
we could
job.
work through it. But
All right.
okay, B's west. All right, that would be if you were standing at A and you're looking out. Then there's a
Yep.
rock in the distance. You'd be like, the rock is west. That is the direction of west. That's west for me.
Okay.
All right.
Yeah.
So that circle on that line, and the circle's a latitude. That's the circle. It's a latitude line. Okay.
Okay.
There's only one point where these lines touch, and you're on that point. So for you to move forward, you can go in one of two directions. You can go on the straight line towards B, or you can go on the circular line. There's no other way to go. You can't be on them both and go forward. Like it's just one or the other.
Yeah. So if I'm on a ball, I got to go around it. If I'm not, I'm
No,
just.
this ain't it. This ain't it. This is just a latitude. This is on a globe. We're on a globe right now.
Oh, this is a globe. Okay.
Yeah, we're on a globe. We're on a globe.
I'm looking basically top down from the North Pole.
This is what Google Earth shows on a globe.
Okay.
B's pointing west because the direction of west would be you see a
Cardinal
rock in the
direction.
distance. You see a rock in the distance. You're like, all right, that rock is west.
Yeah.
You're not going to be turning left or right. That's just going to be a straight line. Even on a globe, like this translates perfectly fine on a globe.
I'll break out my compass. Yeah.
Let me ask
So-
you before you continue, Jeremy. Did you get this idea when I was talking with Bacon yesterday with the tangent line?
No, I thought of it a few hours ago.
Okay, all right.
I forget what days. You guys were in the middle of something. I just popped in my head.
Okay, we're listening.
So you're at A, right? And now you have
Yeah.
options. We want to go east. We want to go east, right?
Yeah.
Like, which line do you follow to go east? Do you follow the latitude line or do you follow B? Because B immediately takes you off of the latitude line. You are off.
Whichever way
If
my
you go down the
compass
B,
takes me, bro.
if you go down the B line, you're off. You're off the latitude line. It's over. The compass is
Obviously,
pointing
the
towards
AB
B.
line, no?
In this perspective, yes. If I'm looking top down with a Euclidean triangle, yes, completely.
Oh, bro, forget the triangle. Forget the triangle. The triangle doesn't matter. It's all about being the latitude line. AB and the latitude line.
Well, the latitude line's a circle, is what so they don't mesh.
Yeah, that's what I'm saying. This like anyone that you can't go east. Like if you're at A, you're telling me you're gonna go east and go on the circle line and not go the direction that east is telling you to go. You can't stay on a latitude line and go east.
You got to go in a circle, according to this latitude line.
According to
circle.
Google Earth, at least Google Earth, if you make a 90 degrees, if you make a 90 degree off north, it points. See, no one's here like objecting to this though. This is like you can't even. There's nothing you can really say to this. Like I don't know if there's even an argument against this.
I guess not, dude.
There's not really much you can
tried
say
to
after
pretend,
this.
but evidently it's just. I'm not
All I see is a
qualified.
circle and a triangle, man. What is this?
So you're
Circle,
at
triangle, thus Earth is flat.
no.
What's
This
going on
is
here?
no the latitude line. If you okay, if there was somebody here that was against me, that would we've been in a heated debate about this for the last 2 days. I don't know if you heard it, but they're trying to say east is on that circle. They're trying to say east is the circle.
That's what I was gonna say too. That's
Yeah,
all.
east
That's all.
is
You're
the
trapped to
circle.
the circle, right? You
Yeah.
can't
How
go
can
along the
east be
line
different
towards
directions,
B.
guys?
You're fucked.
How can east?
Here's the thing. All right, left lane's here. Left lane. We're at A. Right? You see the little diagram I posted?
Yeah, I'm paying attention.
We're at A. There's only one point where the line touches the circle. We're on that point. So if we go forward, we're either going on the circle part or the straight line on the bottom. And those are definitely different directions, right?
Yes.
Yes, those are definitely different directions. Cool. So if we're standing at A and we're like, which way is west? I take my compass out. There's a rock in the distance at B. The compass is pointing towards B. B is also 90 degrees from north. That is west, right? That is the direction of west. Do you agree? From A. We're standing still.
Just
Still haven't moved.
standing still at A, looking west, you're going to look towards B. Yes.
Yeah, so that would be, so the bottom line is the direction of west, right?
From standing still, yes.
From A, yes, that we know which direction west is now. That is the straight line on the bottom. That is the direction of west. Right?
Okay.
We agree on that?
Yeah.
Yeah, so now I want to go west. You're telling me don't go in the direction it's telling me west is. You're telling me to go on go on the circle line. That's a totally different direction.
Yeah. If I tell you to follow your compass heading west, you'll have to follow the circle.
No, we know we're standing at A. We know which way west is. It's in the direction of B, right? And you're telling me don't go west. Go in this other path on the circle.
Well, if you tell you to proceed in a great circle from your location, you'll follow A to B. But if I tell you to follow a westerly heading, you're going to have to go around the circle.
If you're at A and I tell you to go west, do you go in the direction that west would tell you to go, or do you go around in the other direction that west is not going to?
I would, if you say go west, I'm going to follow a 270 heading.
Yeah, the direction of west you'd have to go on the bottom line, right? To go west.
No, I'd follow a 270 heading, which will take me around the circle.
That's not west though.
It is if you're following a 270 heading.
No, we're not moving. We're just at A standing still. I tell you to go west. West is the straight line on the bottom.
Yeah, it's your line of sight. That's where your line of sight goes, way off there to B.
That is the direction of west. I tell you to go west. You're not going to go in the direction of west. You're going to go in a different direction, right?
If you tell me to head west and tell me nothing else, I'm going to follow my compass at a 270 degree heading.
We have this thing right here. You're at A, right? Now, which line? You're saying you're going to go on the line that's not west.
Well, I mean, if you're giving me sort of a mixed instruction, I'm going to say, wait a minute. You want me to go a great circle route directly to B, or do you want me to follow my compass?
Here's the instructions. I want you to. You're standing at A. I want you to go west. All right, now you have an option.
I'll follow
270.
I'll follow my compass.
Do you go in the direction west is from your position, or do you go in a different direction?
I've answered it like 4 times. I'll follow my compass.
So you're not going to go. So you're never going to go west then. You didn't go west.
Yeah, west is a 270 heading as far as traveling. Yes.
West is when you're at A. West is towards B. You're not going to go towards B. You're going to go in a different direction.
Yeah, that's. I don't know what. I'm not sure why you're missing the point of A to B is a great circle route, a direct route, without regard to the heading. Without regard to a heading, that's just that's the direction that line happens to be in, and it is west from point A.
Direction of west.
But
and I'm going to tell you go. I'm going to tell you to go west, and you're not going to go in that direction at all. You're going to go in a whole other different direction.
Yeah, so you need to be specific. Look, you're going to say, look, I need you to go in a direct path to B, which is a great great circle, which is not a 270-degree heading.
No, I'm just going to tell you to move forward west. Go west. You're telling me you're not going to go on the straight line that is west. You're going to go in a different direction. That's nuts. Like, why would you go? Why would you not go
Like I said, if you specify
towards B?
then,
Because B is the direction of west. You're going to go in a direction not west. Why would you? Why would somebody tell you? Why would I
well,
say?
let's
Why would I
say
tell you to go west, and then you don't go in the direction west is? Like,
it just don't. We don't navigate like that. If I'm on my aircraft software, I will plot a line between A and B, and it gives me a heading, and I fly that heading. I don't care what latitude line it's on or longitude line it's on. I follow the heading that that line is pointing at. That's basically how you navigate. You see what line you need to go. You see what that heading is. You put your plotter down and compare it to north and see what your heading needs to be, and that's the heading you go. You don't do any of
So-
this.
all right, let me just sum it up. You're at A. I'm gonna tell you to go west. You're not gonna go west because we know the direction of west is the bottom straight line. You're going to go a different direction. Just to be clear, you're not going to follow the instructions and you're going to go in a different direction of west. Is that what you're telling me?
Well, like I said, to get someone to go in that line, you need to be specific about what you want them to do. Do you want me to follow a 270 heading around the circle, or do you want me to go directly to that line? Because your your compass is going to change. The further away from A you get, the more your compass is going to swing off of a 270 heading.
I'm being very specific. You're at A. I want you to move your body to the west. Go in the direction of west.
That's not specific. That's not specific, Jeremy. It's ambiguous.
That's not specific to tell you
because
to move your body west.
standing there looking, see, I'm agreeing, but I'm agreeing with you that is looking west towards B is a line of sight to the west from A, right? But if you tell me to go west, I'm going to follow my compass and go around that latitude.
Okay, but you would never have moved west if you follow the latitude line. You never actually moved west because west is the bottom line. You would have to step for if you even went west for one single moment. Hold on, man, real quick. We're almost done. It's very clear. I want you to move to the west. That is it. There is a direction that west is. We know that direction. It's very clear. Go west. That is a very clear set of instructions. Move west. How is that not clear?
Yeah, I would interpret that as a 270 heading.
Okay, and you would have
if air traffic control said,
go down the straight
for
line,
Alpalima, I need you to follow a westerly heading. What I'm going to do in my airplane is I'm going to turn to 270 degrees, and that's what I'm going to do.
Okay, forget you're not going to fly around. Okay, so I'm going to tell you to. You're standing at A. I'm going to tell you to move west. You're going to tell me that you are actually not. You're never going to move west because you would have to step off the latitude line because it's the bottom line. You're telling me you're never going to actually go west. You're going to go in a different direction. That's what you're telling me right now. You can't go the direction of west.
Heading is around that circle.
The direction of west is the straight line. That is the direction of west. You're going in a different direction from your point. You're never even going west if you stay on the line.
If we're traveling,
even a little bit,
it's different if you're traveling, though. It's not the same as standing still. And look over there, that's west. That doesn't mean anything. If you're about traveling,
me and you were standing,
you're going to have to be clear about what you want to do.
That does mean something. That absolutely does mean something. If you're standing somewhere and someone says move to the west, move west. That has specific instructions attached to it. It means move west. You're gonna never move west when I tell you to move west. You're gonna stay on a latitude line, which we know isn't west because we know what direction west was from where you were. Anywhere you move, you need to step off that latitude line, or you technically never go west.
If the claim is west as a circle, though, there's no specific direction you could choose.
I'm just saying that's proof that like that little diagram with the tangent point of tangency, that's proof like You're on that point. There is nowhere to go but around the circle or to the straight line. Like, which way do you
Yeah,
go?
but
Do you go
Jeremy,
the direction? Do you go the direction of
which
west, or do you go
yeah,
a
but what
different
you're
direction
implying,
that's not west?
would say that everybody could head west, and if anybody is south from me, they can just go directly north and find me.
I don't know
Right?
what that
We would
means.
all,
I don't know what that means, but
if we all started,
point of
in a
tangency.
line. Let's say we're all in a line along the north south uh, longitude, right? And we all went west at the same time, right? What you're implying is we would stay parallel, and all someone has to do to reach me is just go directly north or south.
I don't know. What I'm saying is that if you were at that point of tangency, and you followed the circle, you did not go the direction of west. You went some other direction and never actually went west because we knew what direction west was from A. This isn't hard. Like, I don't
Yeah,
know
but
why this is
west
so
isn't a set
difficult.
point. That's why it's hard. You're trying to make
When
it
you're
seem like
standing,
west is just one set direction.
the west is definitely a direction from you. It is one set direction from the point A, from wherever you're standing. There is definitely a set direction of west. 100%. You could be standing somewhere and point and say that direction is west. It is a set direction from that position.
It's just a weird argument if once you start moving, west is shifting. So everybody's west is different.
Okay, but before you even start moving, you have to figure what direction am I going to move into? Which leads us to what are you going to take the straight line, the direction of west, or are you going to go on the curved line, not the direction of west?
So there's a guy
Left
standing
lane wants to go
some
not never left lane
distance
go ahead.
from you. But there's some guy standing some distance from you. What direction is west then?
Is the guy to my west?
He's on that circle some distance from you. What direction is west then?
He's on the circle?
Yeah.
Then he's not west because we know west is at B. So if he's on the circle, he's definitely not west.
No,
100%.
no, he's on the circle, but what's west from his position? Say his position is A2. You're A1, he's on A2.
Yeah, well, he would have a
What
line.
direction
He
is
would have a,
west for him?
we'd have to figure that out. And you could go to Google Earth and figure this out. Which way is west for him? You could draw 90 from north, see where that line goes.
Yeah. So,
It's straight up. Like
it's ambiguous. It just depends on your line of sight, and west depends on where you're standing on that latitude. But if you're instructed to go west and travel west, you're going to follow a 270 heading around that circle.
if you go on a latitude line, you never actually went west. I mean, I know it's shocking to everyone, but that's just the facts because you have a point of tangency where the direction of west is and the latitude line is. And if you follow the latitude, we know from where you are at A, the direction of west is towards B. It's on that straight line. And if you choose to go on the circle line, that means you never went west. You never moved forward west at all. You went in a different direction. How hard is this to understand?
So what's your overall like point though? Is just that you would reach the equator, or
You would spiral out. You have to, if you don't step off the latitude line, you never actually went west. So if you follow a latitude line, you're not going west. Or
I'm going to
hey,
my flight software and draw a line. I'll be back in a minute.
left lane, your flight software uses grid north. That's parallel north. That's saying on your thing, if me and you went north on the same latitude, we'd
No,
never
it's on a
intersect.
globe. It's a globe.
I read what grid north is, dude. You said you were using grid north.
well, okay, so you're disagreeing completely that different people in different parts of the world, that their west will be different directions.
Sorry, what?
Are you disagreeing that people in different parts of the world, that their west will be different directions?
Yeah, everyone's west is different unless you go back to the point A. Then that guy's west is always the same from that point.
Okay,
It's
if you
constant
agree,
from any single point.
so you agree west is a circle.
No, if you go on the circle, you never went west, dude. Hell no, it's not a circle.
Wait, so how is everyone's west different? What shape is west, that is everybody's west making then? If it's not one direction,
Everyone's
what is
west
it?
makes the straight line, the A to B line.
Well, it's not always how it's defined, though. Like in the world or whatever with our language, they do define the parallels or circles of latitude as east and west. Like this is from Britannica. Lines of latitude, also called parallels, are imaginary lines that circle Earth's surface running east and west parallel to the equator. But if you go to the definition of east or west, it'll say a straight line, 90 degrees, etc. So it's not actually really in the definition of the word east, technically, that I've seen, but it is used like as going west is a circle. It's like used in both ways in our culture.
Yeah, I'm trying to narrow in on Jeremy's definition, because if he agrees everyone's west is different, then how would you even attempt to lay this out? Like, if it's not a circle, but all our directions are different, like, what kind of projection would ever match that?
Are you asking me for a map or?
Yeah, like on your map, how would you be able to draw any kind of compass for someone? If you tell everyone to go west, everybody's just going in chaotic directions for you, or
well,
it either makes a circle or it's one directional way that everybody can go. Those are the only two options.
not necessarily. So on a dual pole planar Earth, the ones we've been talking about, if you see what I'm posting in the chat, there's actually two different kinds. So you have like cardinal, like north is directly the prime meridian. East is the east on the equator, the straight line of the equator. South is the prime meridian south in Antarctica. And then west is a straight line of equator west. So you actually have a north, an east, a south, and a west, like a compass, like the Earth is a massive compass. But then when you have the circles around the North Pole, you can have east-west circles, and you can have the circles around the South Pole, east-west circles. So you can call those circles east and west in latitude circles. And you have, and actually this is that guy was doing the presentation that in the Quran, it actually mentions there's two different kinds of east and two different kinds of west. And apparently he was trying to link it, is saying that this is what it's related to, that there's like the east on the equator, east and west, and then there's the east and west circles around the poles. But I'm just saying this is the only like map that I'm aware of that actually has a north, an east, a south, and a west that is like set by the prime meridian and the equator, that is not always connected to circles, you know, the way that it is when you go north or south. So it's like both.
Yeah, but then you're setting the implication that anybody over there on that east, if they were to go more east, would not come out on that west side. That's the implication you're setting.
Yeah, it's kind of a separate topic, but if you want to go with that, it's fine for now, that you couldn't get from one to the other if you go direct. But if you were anywhere in the north, like 20 degrees, 30, 40, and then you do your 90 to any of those lines, you're going to end up at the equator, which is east, like the ultimate east, like the east, the equator east. And then if you're in the south, anywhere, which this is a big problem with the AE map, because it works in the north, all looking east on the equinox, you see the sun, but in the south it doesn't work at all on the AE map. You're shooting your east is shooting off to the ice wall. So completely, it's always been another problem for the AE map that was never really resolved. And you know, the globers and just in general, you know, people will say, hey, on the equinox, everybody on all on the longitude, except if you're at one of the poles, but if you're anywhere, you know, 80 south, 70 south, 60 all the way to 0, 80 north, 70 north, 60 north, all the way down to 0 at the equator, all of, you know, from 89 north to 89 south, anywhere on the equinox due east, the sun will rise. That does not work on an AE map. It never has, but it does work on a dual pole, and it does work on a globe. But the point is that east, where the sun would be rising on the equinox, would be like the one east for everybody. Because if everybody traveled that direction, not the circles thing like left lane you guys are talking about, not circles, but actually went a straight line, you would all end up at the equator in one place.
Yeah, but Geo, even your picture implies a set destination where it would be like a pole, a set destination where west is and a set destination where east is. Because Jeremy already agreed everybody's west is different. So how is everybody's west different on that picture? That doesn't make sense.
I think he was saying different from each other, like there's your starting point. Because I mean, he would agree they all end at the equator, or they all run into the equator. This one's a little bit graphically intense, but New Perspective had posted it. I'll repost it. But it kind of shows how the east-west are circles. But if you combine that east-west of circles and the other one I posted with actual north, south, east, west on the meridian and equator, you would end up with like it says in the Quran, apparently, like there's two east and two west, essentially, depending on how you're interpreting it. Whether you're making circles by adjusting your compass and traveling in the heading of west or east, like Leftlane was saying, using the word heading, or they often call it due east or due west, versus the like as the crow flies, which is the tangent off of one of those circles and just go straight, which will lead to the equator.
Yeah, but no matter what, on either of these pictures, you acknowledge you would have to go either northwest, northeast, or southwest, southeast to reach the equator from any point in one of those quadrants. You would deviate from pure west or east. You would have to go either north or south in order to hit the equator in either picture.
Yeah, one of them is a cardinal direction from a spot, and another one is a heading in which you follow and adjust your compass and make a circle. They're just
Well, yeah,
two
I'm
different.
saying I'm working off Jeremy's logic, unless you want to use both in the same example. Jeremy's saying it's not the circles, it's a set direction. So if it's a set direction, you still have to go north or south to reach the equator if you're above or below it.
Yeah, dude, one of them is from one point, taking a cardinal heading and just throwing your compass away as the crow flies and then making a straight line. That's one type, which is a straight cardinal direction from a point, like an arrow that goes from one point to and then just heads that way. The other one is a constantly adjusting, modifying heading in which you continue using a compass as you travel and continue making adjustments to follow a circle, which would be east or west, on a dual pole or a globe or the northern part of an AE map, but not the southern of the AE. But the
My
globe
thing is,
and the dual pole have the two circles.
my thing is,
So
oh, go ahead.
I was just gonna say, can either one of you take one of Geo's pictures and draw these lines that Jeremy is describing without moving northward or southward in your direction? It doesn't make sense.
Yeah, because you're mixing the two reference frames. You're mixing the one of just starting in a spot, getting a cardinal direction, and then throwing your compass away and doing a straight line shot, and then just
That's what I'm
ignoring
talking about.
everything and just taking that straight line. But that's being conflated with the circles. Because if you go off the
No. I'm
circles,
throwing out the circles and telling you guys to draw a line on that map that is showing what Jeremy's saying. That does not go north or south. I'm asking you guys for your example. I'm trying to throw out the circles, right? Because Jeremy, you guys are giving me the example, but every time you give the example, it's on the model of the globe. So on the model of the globe, sure, that's what's going to happen. But if you do it on any of your pictures, you're still going to have to move north or south.
no, it's the same on a globe or a dual pole. This part is the same. It's interchangeable. This particular part. And it's the same on the northern part of an AE map too, and a globe.
I'm failing to see that unless you're on the equator when you draw the line. So if I'm in any one of those quadrants on the two pictures you posted, I'm going to have to move either up north or down southward to reach the equator. You're not going to go pure west or east unless west or east are a direct point on the map.
Wait, say that again? Sorry, I was trying to draw something.
Yeah, no, you're good. And unless west and east are a direct point, like a pole, like the north and south pole, unless they're a direct location, you're not going to be able to draw a line that doesn't deviate north or south to hit the equator.
Are you saying north could be different location for different people? Is that what you're saying?
No, the argument is that, and Jeremy agrees with this. We're saying west is a different direction for everybody, but at the same time, he's saying you wouldn't have to travel north or south to hit the equator. The two,
Yeah,
both of them
I've
can't
heard
be
that one
true.
before. Yeah, that's strange in a way. Yeah.
So that's why I'm asking Gio or Jeremy to draw a line on one of those two pictures Gio posted that doesn't deviate north or south to hit the equator. And unless you make west and east a very set point on the map, you can do that, but then you have to agree that those directions are not different for everybody.
Is that the one you said you got Fight the Flat Earth to agree on? Gio, is that the one?
Sorry, I wasn't. I mean, I was listening, but not quite. I was posting something. What do you want to say that again? Sorry.
Yeah, I said, is that what you guys got Fight the Flat Earth to agree on?
The thing between Jaren and Fight the Flat Earth?
Oh, was it Jaren? Yeah. I think, yeah.
That was about like whether you make circles when you travel. Like whether that was about like if you were at like 20 degrees north and you're going to stay on 20 north, whether you actually have to turn your vessel or whether you go straight, essentially.
Right.
Whether you have to actually turn, whether it's a circle. I didn't
Okay,
hear
so
the thing
let me
that
ask.
anchovies.
Let me ask this: if I start in Canada and pick up another spot in Florida, and we say we'll meet at the North Pole, we're both heading in the right direction, in the same direction, right? Straight line to the North Pole from our perspective locations. Yes or no? What do you guys think?
Not if you're using left lanes grid north, you will never meet because grid north uses parallel lines. So it depends on what map you're using. But if you're just heading north, I would say you would meet. Personally, my guess is you would meet. Yeah.
You would have to, right? The compass is pointing in the same direction, right? No matter where you're at, your compass is pointing north, right? Magnetic north. So if you follow that, you're
Yeah,
going to end up in the same spot, right? No matter where you start from in Earth. Would you agree with that?
yeah. Grid North is on small sectionals that is you take a sectional that's way further north than where you're at. It's going to reflect the difference in the the longitude lines, and they still converge. It's just that what you call the undevelopable surface. It's got the distortion in it and stuff. But my sectionals are not grid. That I actually operate off of the longitude lines. So there's that.
I'm talking in reality. If I start off in Montreal and you start off in Texas, let's say, and we say we're going to meet at the North Pole, magnetic north, we follow the compass, right? Are we going to end up at the same spot?
Of course
Left
we
side?
will. Yeah.
Okay, all right. I just wanted to make sure we're in reality. Okay, fine. I'm good then.
I read it last night. Grid north longitude lines are parallel. They use the
That's
universal
ridiculous. It can't be parallel.
Mercator.
If they converge, how can they be parallel?
No, Grid North doesn't care about it. They transpose it onto a flat map to make it easier. I'll read it again. Hold on. I'll find the screenshot I took.
Yeah, on the map, they're squares. Yeah, of course. But do they converge? How are they going to converge if they're squares? I mean, it's nonsensical. The way they do that.
Here we go. Grid north is the direction of north as indicated by the vertical grid lines on a map, such as the Universal Transverse Mercator UTM grid. Unlike true north, the geographic North Pole, grid lines are straight and parallel to allow for a simple grid system on a flat map. The difference between grid north and true north is typically small, but it varies depending on the location. ... Parallel. Grid lines are straight and parallel. You heard that, left lane?
Yeah, the
Except
part you
they're
said
curving.
before the ... Yeah, the ... part. That's what I'm talking about.
It doesn't go on to do anything else. So do you think the ... part is going to debunk the first part it said about the parallel longitude
It
lines?
said the longitude lines and the grid lines are not necessarily parallel. They differ a little.
You're saying the grid lines aren't, the longitude lines don't follow the grid lines?
Yeah, the grid lines don't represent the longitude lines necessarily. It's just for finding spots with the grid.
So why is grid north and true north, why are they different then?
You know, grid north is only on these maps. Like, I think
Why is it
geographical
different than
maps
true north?
usually use grid.
Why is grid
Because
north different than true north?
they just use it for locating points on the map. It's nothing to do with your actual heading or anything.
It's because they don't convert. They won't. You're not going to meet at the same spot. That's why it's different. Obviously, if grid north is different than true north.
They don't have anything to do with longitude. It's just to do with the map.
Yeah, the map is reality, and the globe is not. On the map, the lines don't converge, do they? The grid lines? Of course not, right?
Well, I mean, there's a little bit of variance. You don't really see it, but usually the sectionals are not big enough that you would see that much difference in them.
That alone should give you pause for thought, left lane.
No, it works out perfect.
Yeah, on a map. On a flat grid map with squares, not converging lines.
Yeah, no, on my sectionals, I don't use the grid on my sectionals. I actually use longitude, latitude, and longitude on my sectional.
What do you mean sectional?
That's a paper map aircraft for planning cross country and things like that.
Dude, why is north different then?
Hold on one second. And the lines converge on that map you're talking about?
Yeah, there's a little variance. Like I said, the sectionals are small enough that you don't really notice it, though. I don't know, maybe if you laid a ruler top to bottom, you might see some variance there, but I don't, when I'm plotting it out, I'm not paying any attention to that. I'm just getting my headings,
Okay, but you're going to miss true north though. If you tried to go north with your grid map, you're not going to hit true north, right?
I'm not using a grid map. I'm using a latitude longitude map.
Using grid north. If when you're using your grid
No
north
grid.
map,
Grid is not part of my navigation system. I don't use grid in anything I do.
Are you using the Universal Transverse Mercator? The UTM?
I am using a sectional map for aeronautics.
What's the name of the map, dude? Please.
I think it's there's WCA and sectional. If you look up sectional maps in aviation, you'll see.
Did he say bisexual?
Yeah, bisectionals.
Dysel's just talking about his plans coming up for the weekend. Getting into it early.
4-day weekend, man.
Got to stay prepared.
Poster map. Take a screenshot with some longitude lines and post it. Anyways, my point stands. Everyone that goes against me has been thoroughly debunked at this point. There is two directions to go when you are on the point of tangency on a longitude and latitude line. And left lane is telling me he's going to go not west. He's going to go in a different direction.
Yeah,
And
it's
yet
due
telling me he's
west.
gone west.
They call it due west.
I'm trying to understand Gio's picture here.
Jeremy, this is
really-
the AI thing. I typed in, is traveling west following a latitude line? And the answer is yes. Traveling due west follows a line of latitude, also known as a parallel, which runs east and west around the globe.
No, I
When you
debunked
travel-
everyone. AI can get it too.
Yeah. But then if you type in another thing, and if you say, is west a circle? It'll say, no, west is not a circle, but it is associated with a circle in a couple of ways. The line of latitude that runs east to west, and the circle the sun appears to trace across the sky. West is
I'm
the
just
opposite
saying, bro.
cardinal direction of east. A circle of latitude is an imaginary line of constant latitude that runs around the Earth east to west. So they're both used in our language.
No, I hear you. But when you're on that latitude line, right? And you're at point A and you're like, okay, that way's west. Which way am I going to go now? I want to go west. So are you going to go on the straight line, which takes you immediately off the latitude line? Or do you stay, if you stay on the circle latitude line, that's not the direction of west from where you are, though.
It is if you follow what they call due west, which is a circle. Because you have to, the difference between those is one of them, you throw your compass away and then you just keep going in that straight line. You forget about east, west, everything, because you just found your one cardinal heading and you just said, that's it. I'm just going to walk this straight line and I'm just going to, whistle to myself and that's it. You're just going to go whistling away. Whereas the other one is you keep your compass in your hand, you keep traveling and you keep adjusting for what they call due west, where you make a circle.
I know, but Gio, when you're standing at A and you have your compass in your hand, and we realize that the compass is pointing towards B on the straight line, like there, the compass is saying this is the direction of west, and then you go and you don't go in that direction. You go in the different direction of the circle. Like you're not just not going west.
Yeah, because
you are if you hold your compass and keep readjusting. You are. That's the heading.
No, you can't go west is the direction of B, right? Like if you want to go west, you need to go in that direction, the straight line direction. That curved line direction is not the direction of west. That's some other direction from where you were. Like I hear you about moving around, and yes, you would spiral out like that. But if you stayed on the latitude line, you technically never went west at all.
yeah,
You have
but
to step
again,
off the latitude.
Jeremy, you would have to imply that west is a set point somewhere
No,
that
I don't have
everybody
to
can
imply
go.
that. I don't have to imply.
Well, again, that's why I asked for an image of what you're talking about, because it can't be drawn. You can't describe what
two
you're
different
talking
wests,
about.
bro. Yeah, you got two different wests. You got fixed west heading like Gio told you, the straight as a crow flies to cardinal direction, and then you've got magnetic west. One's gonna take you in a big loop, and the other one's gonna take you straight without deviating.
Yep, that's why I say, could a compass be our jail bars? Keeps us
Well,
going
yeah,
around
that's
in
what
circles.
I always said. Operation Broken
Well,
Compass, bro.
I'm
You want to
fine with the
fucking
true west. I'm fine with the true west, but you can't also say that everyone's west is a different direction.
So
Jeremy's trying to say both
depending,
exist. That doesn't make sense.
well, depending on where you set sail from, right? What coastline you set sail from, not all of those west might intersect. Like, if they did intersect, I would be leaning more towards the globe model, but I'm
I didn't
not
say anything
necessarily
about
leaning.
intersect.
But you said the same direction.
Well, yeah, they would be parallel. I tried to come up with an
Yeah.
example earlier, and he said, no, that's not what's going on. He said everybody's
well,
west would be a different way.
No, I don't see it that way. I see it them all being kind of them all being parallel. But again, you have to presume the nature of Earth shape in order to conclude that, but prior to validating that.
Yeah, also the
Well,
words east and west actually come from the sun. Like west means evening, so like when the sun's setting, and then east comes from toward the sunrise. I'm looking in the etymology, so like toward the sunrise. That has to do with like shining and rising in the dawn. So that it's even more so. So like when the sun is on the equator, it's the same east for everybody, because like if we talk about two different kinds of east, one of them is the equatorial straight line of east, which when the sun is on the equator, east is the same for everybody because you're all looking at that east, the one east that is the equator east. But at other times of the year, when the sun is in the north circling the North Pole or in the south circling the South Pole, the east is going to be different depending on what latitude line you're on and what position the sun is in for everybody. It's going to be slightly different throughout different times of the year. That's why the equinox is unique in that way, because it's the same for everybody. Because you're on the one universal east, basically. Whereas the other one, when it's doing circles, it's all kind of in a relative east, depending on where the sun is and where you are in that circuit.
No matter what shape you assume the Earth is, west can't be. It has to be parallel if west is a certain way. Doesn't matter what shape you choose.
Wait, I wasn't really paying attention. You're saying the Earth shape doesn't matter, and when it comes to west being the same direction.
When it comes to what Jeremy's saying, that west is a different direction for everybody, and if you hit west, and when you go west, you reach the equator, but you also don't go north or south doing it. You can't do that on any shape.
Yeah, I don't know. Jeremy says wild stuff, bro. You gotta remember, bro, he works with a lot of, cleaning products. So
What I'm saying about this west east thing, it's just steel manning the globe. It's geometry. You know what I'm saying? Like, you can either go on the circle path or the straight line path. One of them's west, one of them's not west. You know what I'm saying? Like this, I don't know.
But they're both used as west in our language. Like we use it, we call it due west or traveling west on a latitude line, a small circle. And we would call it a cardinal direction from one point. It's a direction of west. So, I mean, they're both
I hear
used.
you. You've technically never went, if you stay on a latitude line, you've never went west though. So, like, technically.
Okay, but
But
Jeremy,
you
again,
did,
draw
you
me.
did under the definition of it being a circle that you're the due west. That's why they put the word due in front of it.
I mean, under that definition, but under
Mountain
the
Dew.
actual direction of, under the actual. Go ahead, Dice. I'll get your joke out.
I said I'll step it up a notch and put mountain in front of the dew. But my bad, Jeremy. Go ahead.
Hey, according to that definition, sure, but according to the direction of west and the geometry of it all, you technically never went west. You never went in the direction of west at any point if you stay on the latitude line. You'd spiral out. Even with what you're saying, checking your compass, you take a step forward, check your compass, adjust, take a step forward. Even doing that, you'd spiral out to the equator at some point. Like, I don't agree with
Wait,
those definitions.
you're saying west is a spiral?
Depends on how often you want to check your compass. If you never check your compass,
Are you adding Coriolis into this or something, bro?
if you never check. Did you get your joke out or?
No, I'm being serious. It's just like, just trying to figure
No
it out.
Coriolis. No Coriolis with this. I'm saying depending on how often you check your compass, you could never check your compass again and it'd be a straight line. Or you could check your compass, every mile and spiral out.
Yeah, so there are two scenarios. If you're standing at a latitude line and you give someone a compass and he pulls it out and he's got the north and he's got his west, and then you tell the guy, okay, travel west. And the guy's like, this way? And you're like, yep, that way, 90 degrees, yep. And you send him in that direction. And then you grab the compass out of his hand and you're like, bye-bye, have a good day. Then yeah, he's just going to keep going in that straight 90 degree and he'll end up at the equator and all that. However, the other scenario is if you give him the compass, same thing, he turns 90, and then he starts walking and you say, no, keep looking at your compass and keep following west. So if you made a compass that has, it would have like a cross, like you put another, instead of just the north-south, metal thing, you could just put another one that shows the west direction. And then you would just say, keep following that west. And then you didn't grab the compass out of his hand. You let him keep it. You told him to keep going. Keep looking at the compass, dude. Keep looking as you're going. Keep looking as you're going. Then he would follow the circle of latitude because the compass will keep changing just minutely. Every little tiny step he takes forward, the compass goes and makes a little step as well. So he moves one step. I mean, it is a little bit technically like a disco ball latitude line because you're going like straight a little bit and then you're readjusting. You're going a little bit. So it's kind of a jagged circle technically, unless you're like in an airplane or something where you can just turn your wheel or whatever, like, or in a car maybe where you're not like taking step by step. You're just in one continuous, turn of your rudder in a boat. And I mean, obviously you couldn't do that with all the currents, or an airplane, or I guess maybe say like a car with a wheel that you would turn a tiny bit. Then in that case, you really would never take any jagged lines. You would just have your wheel perfectly turned, and then you would just keep following that west direction, which would be a circle.
Yeah, I think we all see the two different ways, but let's go with the one with no compass, since that's the one Jeremy's talking about. Now before I send you off, sorry, I got muted. Before I send you off in that direction, what if I ask you the question, are we north or south of the equator right now? What would you say? Unless north and south are in contention too at this point.
I don't know if he's going to respond. I was looking for the other from that guy's Quran. I was actually looking for the one that talks about the 2 east and 2 west. Go ahead, though. I don't know if he heard you.
What was I supposed to say it again? I wasn't listening.
Before I send you off in the direction of west, what if I ask you the question, are we north or south of the equator right now? What would you answer?
Oh, well, if we were north of it, I would say we're north.
Okay, so wouldn't you logically, if you end up reaching the equator when you go west, wouldn't you logically also have to contemplate how you also went south if we were north of it?
Yeah, it's crazy, right? You could just go east or west and also go south at the same time while never actually.
Yeah. So it's almost as if you went southwest and not actual west.
I know, that's why Gio asked me like, what direction is it? It's like, bro, I don't know. Like the latitude line, like what direction are you going? Like, is it 89.999? I don't know what degree you're going, but it's not.
The only reason it's confusing you is because you don't want to make it a circle.
Well, it's just not a circle though, because as in my diagram from A to B, that's the west one. That is the direction of west. So if you go in a direction, so you're standing at the point of tangency, you can either go on the straight line or on the circle line. The straight line is the direction of west. That would be the direction I would go if I wanted to move west. I'm going to go in the direction of west. You guys are saying, no, go in this other direction on the circle. Like, I just wouldn't go on the circle one. That's just me, though. I'm good at following instructions.
Yeah, but if you end up at the equator,
you would if someone gave you a compass and told you to keep following what the compass tells you. then you would make a circle.
You'd spiral out. You would make a circle. It'd be a spiral.
No,
You'd
not
spiral
spiral.
down.
No, you would stay right there on a circle.
No, you can't. No, I would never go on the circle point because the circle one is not the direction of west.
It is, because the
You-
second you take your first step forward, the compass has changed a teensy tiny bit. That by the time you put your foot down, you're still on the circle.
No, there's a
The compass
there's a
changes.
point.
You're in a body, and your 2 feet are in the same place. You step 1 foot up, you start moving forward. As your body moves forward, just a couple inches, technically the compass has moved a tiny bit. That when you land your foot, you're going to be on a circle, and you keep doing that, you make a perfect circle.
No, I mean I hear what you're saying, but you technically never went west if you keep doing that.
Come on, Jeremy.
Bro, if me and you were on the same spot, right? We're at this point of tangency on the line. There's a line, the straight line, and then the circle line. Now you stay still. We're right on top of each other. You stay still. I move forward on the straight line and ask you, did I go west? Well, you would say yes. Now, if I went on the circle line and asked you, did I go west? You would say, no, you didn't go west. So,
In a practical
like,
sense,
if it was a test, if this was a test, anyone going on the circle path you'd fail.
Dude, just call them 2 things. Call one of them west and one of them due west, because that's what society calls it, due west. So
Well,
just
I
call
kind
one
of
of
had
them
it
west
backwards
and call
too.
one of them due west. Due west is
Well,
the circle. West is the straight.
his
Well,
west is also
I had it the
southwest
other way
somehow.
around. I had due west as being the straight west, and west being the magnetic west. Because everybody always assumes, when you're going to travel long distance, you're going to be using a northern guided compass because that's just kind of how the system works. Like SE pointed out, it's kind of the bars on the jail cell. In my opinion, that's how I see it, dude. It's the invisible bars.
Yeah, bro. West cannot be a circle. Cardinal direction. Think of a cross. Think of how they show it. When you see the rooster on the roof, you have like the cross thing: east, west, north, south. Right? It can be a circle. I know
Well, then
that's what the compass makes you do, but it's not logical.
Well, then southwest and northwest don't exist. As you go west, you reach the equator, but you never traveled north or south at the same time. That
Yo,
makes much more
I'm
sense.
cool. I'm cool with west
Well,
being a
like I've
spiral.
always said, I don't know. Jeremy's got it mixed up, but any direction other than north, if you travel straight, right, not using the magnetic compass, you'll end up going towards the edge of the outer edge, right? Like if it's not a globe model, if it's a fucking globe model, you'll just do a big circle. So
Think of a cardinal direction. Think of the cross, right? North is that way, south is the other way, then the other arm of the cross, east is that way, west is that way. It cannot be a
Yeah.
circle. Now, it is when you follow the compass, yes, but in reality, a cardinal direction can only be one direction. It
Yeah,
cannot be
but
a
as
circle.
I agree on the cross thing, but if you're agreeing with Jeremy, you also have to acknowledge that you're traveling north or south at the same time if you reach the equator.
North and south at the same time.
no, I don't agree
Yes,
with that.
because he's starting north of the equator, heading west, and then reaching the equator. How did he
So
move
you're doing
southward?
2 things. Yeah, you're doing 2 things in that scenario.
Yeah.
One of them is you're starting at one point and you're traveling in a direction of west from that one point. Only from that point. If you're in Dallas, Texas, and you take a compass and you get your 90 degree to west, and then you throw your compass away and you just follow that straight line, you're going west from that Dallas, Texas. However, on the overall scheme from like a God mode, as you're traveling, if you don't keep readjusting, then you're not going to make the due west circle around. You're going to actually go straight and make a straight as the crow flies. And then from that perspective, you will be going southeast, southwest or whatever. Yeah. So one of
No,
them
I'm ignoring.
one of them
I'm
is as
ignoring
it's
the
defined.
circles.
One of them as it's defined from a point as a direction from a cardinal from that point. The other one is a constantly moving, direction based on traveling.
No, guys, we got to get on the same page here. Jeremy said, I'm using just Jeremy's example. I'm leaving out the
Dude,
circles.
nobody
I'm leaving
agrees
out
with
the
me
globe.
though. Nobody agrees with me. So you're like, don't argue
Well, so
against them with what
so
I'm
the
saying
thing
because
Wait,
the
they
thing
all
is,
disagree with
Geo is agreeing with you though. He's trying to make it seem that way.
Oh, does he?
well, I think what Geo's trying to tell you is like it's possible to go like northeast and end up in the southern hemisphere, loop back around, and then go southeast, right? From a globe perspective. But you can't go north and south at the same time, bro.
Oh, that's fucking brilliant. I'm writing that one down. Hold on.
No, what I'm referring to is if you guys look in the chat, this thing that I made on Google Earth. So that let's just say that's Texas or wherever that is. I think it might be closer to Alabama, but who cares? Let's just say that's around Texas. That 90 takes you down to the equator. So that would be east from that point. A direct line of east. You throw your compass away. From that point in Texas or whatever, that's east. But if you forget about the point starting from Texas, of course that thing is going south. It's going southeast. So it's like two different reference frames. One of them is the east from that point, simply defined from that point, a cardinal direction. The other one is the actually traveling direction, which from like a God mode, like we're looking here from this big beautiful Jesuit ball here, is you're going down. You are going southeast. Is your actual heading, and to actually do a heading of east, you would have to keep readjusting, and go around the latitude line.
No, I think if you were doing this, if you were going southeast, the line would be sharper. It'd be like in between south and that line.
You have to go southeast to get from 30 north down to the equator. You have to.
You'd be drifting south. Yeah, yeah, yeah.
It's south,
You'd be
right?
like, yeah,
But
you'd be
from
like,
that
it's like,
point, that's east. That's 90 degrees. That's the cardinal
yeah,
direction of east from that point. So it's both,
exactly.
depending on how you define it, which is how society does this, like the English language and how it's used. And they use the term due east and etc. To define that.
I realized they they colloquially say that, oh, China's in the east or whatever. Yeah, but like technically speaking, it's like northeast or something, or you know what I'm saying? You have to be like, which way is China? You know what I'm saying? Is it really east? East pointing at the equator. I hear you though. I hear you. I'm saying I'm cool with east being a spiral or a straight line, but not a circle.
It's two different ways of defining it. One of them is a cardinal direction 90 degrees from north from a point. The other one is a constantly adjusting compass, which makes a circle, a clockwise or counterclockwise circle, depending on whether you're going to east or west, around one of the poles.
I know I hate the second one though, because you, like I said, you like technically never actually went in the direction from any one point. You know what I'm saying?
Well, that's the whole point. That's the whole point to it being the invisible bars on the jail cell, right? You'll never reach the edge using that. You always travel parallel to it.
Well, that might be actually how they're keeping us entrapped on a dual pole Earth, is that you actually would never do an as the crow flies, like in a straight line, enough to actually get to the edge, basically, or to the outer rims. Because if you take a sphere and you project it onto a plane, basically, like you have the two poles, then instead of a globe, you can go round and round and round. But on a two pole, you can only go around one of the poles. You can't just go around the whole thing. But that's what New Perspective says. Like, who's actually doing that? Like, who's just doing an as the crow flies straight line and just shooting
No,
off?
nobody's doing that. That's the whole point.
Nobody,
Like
exactly.
I've asked a lot of Glovers for years about it, and they say that they don't really have a way to reference a straight tangent when you're just out in the middle of the ocean, right? Like they don't have an instrument to do that with.
But they do, bro. It's called a gyro compass. They do. They don't get it.
What do you mean? I don't
That's
get
what
it.
the gyro compass does. Yeah. But they'll have you believe that it always points north, but you can make it point to any cardinal direction. You spin it up in that direction and it stays that way.
Yeah, I think you could do it with the stars too. Yeah, gyro compass possibly. I mean, depending on
Well,
how
no, the
accurate
stars are
it is.
moving.
The stars are moving, yeah.
No, but you could still plot. You can still get a freeze frame of the sky by adjusting it for 4 minutes every night. I'm saying if the stars are
Difficult.
circles. Well, I mean, if the stars are circles, you could do a tangent to one of those star circles and then just keep adjusting. It would be difficult to do, but it could be done.
Yeah, I'm sure it could be. I wouldn't be the guy for that. You know, I'd be questioning myself in the second you got spun around a few times because of a fucking storm or something. I'd be screwed. So I do like SE's idea. I'd have to kick that around a bit. I don't know if that would work though.
That's why when
You're
you
saying
said
that
broken compass,
you're
right?
saying that
Operation,
you're saying that it's not going to process.
no, that's exactly what it does. It keeps rigidity in space. You could probably do it with a regular gyroscope.
Well, don't the Glovers claim that it processes?
That's what they claim, yeah, but I found information and I've posted it that even a gyro compass, a mechanical one, you can make it point to any cardinal direction. I posted it a few
Yeah,
times. I can try to find it again.
I understand that. I'm not saying that you can't fix it on a cardinal direction, but what I'm saying is, how do you prevent that whole drift effect from taking place?
It doesn't drift. If you keep it at a certain RPM, it doesn't drift. That's exactly what it's meant to do. It keeps its rigidity in space. Unless you don't have good ball bearings or whatever, but that's what a compass, I mean a gyroscope does. It
Yeah,
keeps
and they
its
claim that they're
rigidity.
so accurate. Yeah, they claim they're so accurate. Like they use them as backup in case like GPS goes out or in case something else happens. Like they use them
Yep.
like in the ocean so they can know where they're going.
Yeah. Apparently any boat over 30,000 tons has to have one of those aboard.
It does seek true north too.
You see, that's what they have you believe. But yeah, it does. But they have it. They make it do that by weights on the bottom and so on and so forth. But even those, a gyro compass that seeks north, a mechanical one, you could make it seek east all day long, or southwest, or whatever. You can set it.
Yeah, but again, SE, I'm pretty sure that's using some sort of like magnetic declination.
No, bro. No, that the whole thing is they use those because the boats, when they were metal, they would set the compass off. So it's directly designed not to be affected by magnetism. That's specifically why they made them.
Yeah, people think of like when the fact that a gyro, because a gyro compass is different than a compass, and people think of a gyro compass as if it uses magnetics, but just because it has the word compass in it. But it's actually
exactly.
but it's what SE is saying. It's not affected by magnetic fields. It's meant to stay rigid.
Well,
So
let me ask you, Gio. You're not Canadian. Do gyroscopes precess?
what does Canadian have to do with it? I've been to Canada. I grew up in Michigan, which was close to Canada, so I'm almost Canadian.
Close, but no cookie. But do gyroscopes precess?
What kind? Mechanical? Ring laser?
Yeah. No, just mechanical.
No, they don't precess, bro. The only precession is if the ball bearings are not good, right? But that's specifically what it's meant to do, to keep its rigidity in space, regardless of what the base does, what anything does around it, right? That wheel stays in the lock position, assuming you keep the RPMs.
So
I
just
think
a
it's
quick search here on AI.
10,000 or
It says they do. It says gyroscopes precess when external torque is applied to them. Blah blah blah.
yeah. If
Precession
you
is the
apply torque,
phenomenon where the axis of the spinning gyroscope rotates in a third direction rather than uh, falling or tilting in direction of applied force instead of following the gyroscope swing around the cone in a cone. Precession caused by torque. Change in angular momentum. Simple tilt.
Yeah, so I mean, they claim that it precesses along with the curve of the Earth. If you replace, the rotation of the Earth, if you replace rotation of Earth with ether drift, then let's just say ether drift / rotation of Earth, whatever one you prefer, would cause a precession. But a gyro compass has mechanisms that counteract that, so it stays rigid.
Yeah, the spinning itself is what causes it to stay rigid in space. I mean, that's the whole thing. That's the whole thing of.
No, I understand. I get that, yeah, but I'm trying to make heads or tails of it because I'm hear a lot of the Globers making these talking points of precession. But you're saying there's a different gyroscope that is made not to do that, and I would expect that. Like if you can keep like a consistent RPM, right? Like what would be there to cause it to precess? But if they're saying this is like Coriolis evidence, then
Well, they're
that
saying.
means it's.
Well, they're saying that the gyro compass seeks north, right? Now, if it precessed, how would it seek north? Think about it. The gyro compass that the ballers use and says it precesses, right? Well, if it
Well,
did
I
precess,
never said
then
it
it
seeks
wouldn't work.
north.
Yeah.
Yeah, that's that. I've never made that talking point.
Now, mind you, it has to be a well-crafted gyroscope, right? Or gyro compass, like the ball bearings and all that. It's got to be like, finely crafted. But even a toy one, get a toy one, spin it up, and move the base, and you'll see it stays there. The wheel stays exactly where you spin it. You can move the base up, down, sideways. You must have seen that, right? And the wheel always stays rigid in space, assuming you keep the RPMs. Once it starts dying down, then it'll process, right? That's very important. It has to have constant RPM. And I think it's 10,000, something like that. There's a minimum. 8 or 10,000, 12, something like that. That's the sweet spot. But it has to be constant spinning. That's the trick to it.
We should do it, man. We should go find the edge.
Well, I've been asking for years, but they tell me, well, you got to build one, and you need like a $10,000 one, or yeah.
Yeah, I think they're quite expensive. The really fancy ones, gyro compasses. Yeah, I would like to get one of those and check it out. Maybe just head off to the ocean, maybe with no food and water, and just head for the edge and see what happens.
Yes, go. That's it. Make it point south, and like Dyslow said, Operation Broken Compass. You just keep it. You keep going that way, right? But instead of a compass, you have the gyro compass. Here, I'll try to find a video where the guy clearly states it, so you don't think I'm making it up. I know I have it saved. And of course, I don't have it saved. Damn it! I know I saved it somewhere.
All year round. So, but I mean, traveling there though, like in a vessel in that cold.
I mean,
I'm
it
sure
was warm enough
they take an
to
airplane.
do a shirtless photo, right?
Yeah, during this 24-hour sun time. Yeah, but I'm saying if you wanted to get to the Edmonton station and you did not have GPS or airplanes or anything, and you just wanted to walk across the ice, which I know would be like near impossible. Let's just say in theory you could. You'd have to have like some kind of gyro compass if you can't see the stars. If you could see the stars, you could use the stars, but otherwise you'd have to have a gyro compass because if you used a regular compass, they say you'd end up off in the ocean, out in the middle of the ocean somewhere, not in the center of Antarctica at the actual 90 south.
Yeah, there it is, guys.
Well,
See
if
for
you don't
yourself.
see, I mean, if there's no extra stars and every star's got a GP, then you can. It's like, why assume that there's more land? You know.
Well, but have we been to every GP of every star to know whether there's land out in the ocean that you know what I mean, that we haven't been to? I know what you mean though. If there's a land under every star and we can see all the stars, then the hidden land would have to be somewhere under one of the stars that we see, or it would have to be like beyond the star field that we see, you know, be in the outer ponders kind of thing, or the outer worlds or something, in some other place under a star that we can't even see. Would be another possibility. So it's either the hidden land would have to either be under a star we can see or somewhere under a star that we can't see. Stars beyond, if there are stars beyond, or any other stars.
So Dyslow, I posted it for you, bro, and whoever else wants to see it. Clearly, the guy states you can make a gyro compass point to any cardinal direction. So the fact that they tell you it always seeks north, yeah, that's because it's set to seek north.
Well, okay. I mean, I didn't disagree with that, but my point was like traveling, keeping it fixed in that cardinal direction. Is
I'm not
that
saying you
possible
disagree.
over a long
Get me wrong.
distance, time and all that?
Yeah. I'm not saying that you disagreed with me, but I just want to post proof of what I said, so you don't think I'm making it up. It's all about keeping rigidity in space. That's the whole thing of it.
Yeah. Yep.
So you take out your regular compass, right? You find south, right? Then you spin up your gyro. You set it to that location exactly as the compass. You throw away the compass. The compass is no good anymore, and you follow that direction. Or if you
Alright,
don't, you'll be
well, we
going
got it
around in
resolved.
circles.
Right on.
Now they say even that after a while, because of the spinning and the torque of the wheel, that it might drift off a little bit. So it's not 100%, right? Because of the ball bearings and all that. But I mean, in general, it just points one direction.
Yeah, dude, if you tell Alan that there's multiple GPs for a singular star, he'll lose his shit. I would say with Stellarium and I think how advanced we are, that probably the only possibility left is that any extra land is outside the star field or has a different field that we can't see.
I think that's why they keep us out of Antarctica. One of the reasons. They may have found tech there, and there's definitely more land. Now, I say that not out of a whim, because of what an actual compass does not do. The actual compass using the magnet, right? The flip thing, we've talked about it many times. It appears that it's like a monopole, and that's impossible. We cannot be on there's no such thing as a monopole, right? So, yeah.
Yeah, if you get to the 90 south and it looks like the equator, but it's not merging with the northern hemisphere, then there's your giveaway right there. So maybe that is why they're keeping us away from there, because maybe there is, once you get to the 90, then you can start to see the convergence of, a third star field. Or I guess, I don't know. Yeah. I don't know if you would call it a second one because there's one for the south and one for the north. Or are we going to still call that singular? I think it rearranges and invokes a lot of questions.
Yep, indeed. Look at what I posted. See how a compass behaves? That's how a compass should behave but it does not. It always points to one direction.
The north and that being the North Pole and the south being the South Pole?
Yep. Look at the compass when it's near the middle, let's say the equator. Notice how it's pointing the other way?
Well, the red is pointing to the north and the white's pointing to the south on both above and below the bar. Like it
Look at
wouldn't
it
flip.
again. Look at it again. Look at the north one, look at the south one, right? And look at the one in the middle on top. Are they pointing the same way?
No, because when you go past the pole, it flips.
Exactly, but it doesn't do that in reality.
How do you know?
Well, has anybody ever seen it? And you see, there's pilots. They fly over the North Pole, and the compass points in all different directions.
Well, the south one, the magnetic, they claim is off in the ocean. So I guess somebody would have to go to that spot in the ocean and see it flip, if that's a thing. I've never seen a video of that or anything. And then the north one, like, I mean, I don't think no one really goes to the North Pole, let alone, you know what I mean? Like, has anyone gone to the magnetic north or south and then actually taken a compass and traveled for miles past the point to see if it flips?
Yeah. There's a military plane. I posted the video many times. I'll see if I can find it. Yeah, there's a pilot that says, "Oh, it's pointing in all different directions," and it shows it, like freaking out when they fly over the north. The north magnetic pole.
But does it flip? It might wig out a little bit in the zone because it's like a vortex zone or something, but does it flip like once you get past it? I mean, it would have to, because like if you're in like yeah, go ahead.
No, you go. It doesn't show it flipping. It just shows it pointing in different directions. I'll see if I can find the video.
Well, I was just gonna say, like, on let's just say on the globe for a minute. It'd be the same on an AE or a dual pole, but let's just say it doesn't matter. Let's just say you're in Canada is like opposite of Russia, sort of. Let's just say, right? Just in general, 180 degrees. So if you're in like Russia, somewhere over there, and then your compass would point to the north, then if you flew, in theory, across the pole, or if you flew around one of the latitude lines, either way, and then you're over in Canada, you'd be pointing towards the north. But those two are 180 degrees from each other because they would both be looking up at Polaris at their north. So the compass would have to flip somewhere between those, don't you think?
Yeah, that's my whole point. Yeah. And there's no proof of that. Here's the video, by the way. It's a short video. You can see for yourself. The pilot says it himself. They can't rely on the compass. They have to use the satellite, they say. Yeah, Blue flips out when I talk about this. They all flip out. Oh, you gotta be in outer space and blah, 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 blah. Sure. So I guess you don't believe the military pilot, Blue.
Yeah, I wonder. I mean, that's the Weather Channel. That could be psyopy, but I also wouldn't. I mean, whether that's like real or not, or whether that's deceptive or not. But either way, like, let's just even on an AE map or a dual pole or a globe in the north, all of them. If you have Polaris at the center of the rotation, of stars and all that, I mean, the compass would have to flip at some point, because if you're going north, you get to where the pole is, and then you just keep going north. Well, eventually you'll be going south. You know what I mean? And then the north will be 180 degrees behind you once you get past the pole. So it would have to flip somewhere, because like people in Russia and Canada are seeing 180 degree flipped compasses, and they're 180 degrees on the other side of the pole. So it seems like it would have to flip somewhere, but maybe it does wig out though. I wouldn't be surprised if it goes wigs out when you get right there. Like, because what else would it be? It would be like an exact point. You know what I mean? Like you could go right over it and be like flip, 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 flip. With if you got right to it. But it might be like a zone, like a huge zone of like 30 square miles or whatever, to where in that 30 square miles where the pole is, it might go all crazy until you get past that 30 square mile. I'm just making up the number 30, but until you get past that region to where then it would be stabilized in its flipped state. Like it would be, you'd be flying south at some point.
Right, and the question is, has anybody seen their compass flip no matter where you are? It's never been demonstrated. I've never seen it. Anybody? It always points north, no matter where you are on this, whatever we're at. It always points north. I'm just saying it's something to think about. I don't, I don't hear a lot of people talking about this, but to me, it's so obvious, right? It's like there's no such thing as a monopole, right? So we have a compass that shows monopole behavior. That cannot be. That cannot be. That is impossible. Who wants to take a compass to outer space? Yeah, of course, all the people that navigate, they're in outer space, right, Blue? Come on, man. Now, I've heard people say that, who was it? I think it was Whitsett I was talking to. He says, and other people told me that it could be aligned north-south, right? So in other words, the south is down in the ground. See what I'm saying? But to me, it's aligned horizontally, not vertically. 'Cause, you have to hold your compass horizontally, right? If you do it vertically, it touches the bottom, right? So the south, where is it? Where's the South Pole?
Look into a ring magnetic field of like a ring magnet.
Yeah, but it would still have to have two poles. There's no such thing as a monopole.
Yeah, I understand, but they're parallel to one another.
Parallel? What do you mean?
You understand what the shape of a ring is?
Yeah, I get it, but they say that the Earth magnet is like a bar magnet. So take away the ring magnet. I know what you're saying, but they say that the Earth's magnet
They say a lot of
is.
things.
Yeah. I'm just going by the current pseudo model.
Well, maybe that's the problem.
So you're saying it could be a ring. A ring. Okay, where would the south be? All around, like the ice ring? Is that what you're saying?
Yep.
Okay, but if you get close to the south, the same thing would have to happen, right? There would have to be a flip somewhere. Would you agree?
Depends how far south you went.
Yeah, yeah, of course. Like take a compass and a magnet, bro, and I mean, we've all done that as children, right? It's pointing one way, you turn the magnet, you see the compass turning. It's that simple. It's not rocket science. You don't have to know math or physics or geometry. It's very simple. It's a kid's toy, right? We've all done it. We've had a compass, we flip it, and we see, the bar flip. When you turn the magnet, the north becomes south, and the south points north. It's child's play.
Yeah, but that's a bar magnet.
Even a ring magnet, same thing. If you flip it,
No, I don't think so.
it would have to, bro.
I can't argue. Can't argue it right now though, because I'm in the middle of a show with my family.
I hear that. Well, get a ring magnet and try it.
It's kind of crazy how topics come and go. It's like, yeah, I had something to say about that, and then it's gone. And now I can't even recall what it was, so it must not have been that important.
It'll come to you. This is not difficult, right? Magnets behave in a certain way, compasses behave in a certain way, and there's no way around that. You can't change that.
Well, to me, it's simple, but I've played with them for a long time since I was a youngin'. I had a little laboratory down in the basement when I lived up in BC, and my stepfather, like, if I did good in school, I could request parts like different magnets, different kinds of wire, different kinds of, so I could experiment on my own. And it is quite simple. Electromagnet, spherical magnet, ring magnet, bar magnet, under the ferro film that I had at the time, which didn't have any color. It's not like the ferrocell stuff that Tattoo Monkey's got or anything, but it did show you. You could still see the shape of things, and it didn't matter how you married the magnets together or whatever. You take them apart individually under the ferro film that we had, which was just basically like a black and white presentation, and it's the same field geometry is displayed. But yeah, to me, what you're saying is common sense, but that varies from individual to individual. And like navigation, I traveled commercial flights, intercontinental and not, and I can tell you whatever the hell the shape is, this place is huge. uh, the, yeah, I still can't recall the other point I was wanting to share though. It was relevant earlier.
Was it maybe a monopole when I was talking about a monopole? Or the alignment of the field?
Well, that's like I can take or did and have again. I've recently reproduced the results, I guess you could say. Which when I originally did it, I was just playing around. I took 4 spherical magnets and put them in a tetrahedral alignment. Right, if you draw on center point to center point, and it didn't want to go there, but I eventually got it to lock in place. And I would draw another magnet. I would disturb or perturb is what people like to use now. Perturbate. Yeah, that's the word. But I would disturb the field with another magnet in proximity. Right. The weaker the magnet, the larger volumetrically the field is. The stronger the magnet, the smaller volumetric the field is. And anyway, I could bring a weak magnet within proximity, and they would fly apart violently because of the Gauss to the spherical circumference, whatever you want to call the spherical volume of the actual magnet themselves, and the field being small enough to be able to release. Like you can do the same thing with a weaker Gauss or a smaller diameter or sphere, right? Volumetric sphere of the magnet. So yes, when you interfere, there's all kinds of stuff that occurs when you bring them together in different orientations.
Right. You have coherent and incoherent. when you get the balls and you put them in a line, right? They behave a certain way, but then when you crunch them up, when you put them all together, they behave in a totally different manner. That's something else, but you get what I'm saying with the compass, right? You've done it as a kid, obviously, right?
That way.
Definitely. The compass was part of the experiment with the electromagnets, so I could recognize what was going on. I got lucky, right? My stepfather was rich as 6 foot up his bull's ass. And to him, the way he worded it, education was paramount to a child. So as long as we did good in school and got good reports from school and from our mother, we could get basically whatever the hell we wanted. And that's the stuff I was interested in. And he hooked me up with a bunch of stuff, and it gave me a head start on recognizing and familiarity with it, to where it served me later in life. I become a technician, engineer, etc. So yeah, it helped. But compasses was key in me evaluating the fields, especially using forming electric coils. Because I was tearing apart stuff like speakers and the voice coil, and how the hell does this work? But yeah, I'm definitely familiar with compass, polarity, and what a lot of people don't recognize is why the north part of what we call a magnet is attracted to the North Pole, what we call North Pole, is because it's actually magnetically south, right? I mean, most people aren't aware of that. That's like throwing a kink in the spokes, and I don't want to confuse
What
anyone.
we think is north is actually the South Pole. That's
correct.
Like the anode, or whatever.
Yeah, most people think north means the North Pole, but it's actually the South Magnetic Pole.
Yeah, flow of North Pole magnets towards
the north, because it's attracted to the South Pole. But that's magnetically speaking, right? Not cardinally. And alleged evident rotation, right? Of something, whether it's the Earth or everything around the Earth. What the hell? Something's going on, and has a sequence and a pattern that we observe and record and have for a long time. A lot of people see it as a calendar, but a lot of other people recognize it from far before that, zodiacal, and symbology through every culture throughout everywhere, having similar symbology of what we call time, season, astronomy, zodiacal, zodiac.
Well, the Chinese had a compass that would point south way back in the day.
As long as it points in the direction that you can reference, that's all you need. That and the stars.
Yeah, you need a reference point.
Yeah, but my grandpa, he didn't. That was so weird. It didn't matter. You get blindfolded, spin him around. We did it over and over trying to fuck him up. Got him, let him get drunk, did it again. And he could just point north, south, east, and west. It didn't matter. And some people are just like that. Like, the water witchers, the people that can douse water legitimately, accurately.
I was just going to say, I bet you can find water too.
Yeah. I sure wished I would have asked way more questions and learned when I had the opportunity to, but I didn't recognize. I was caught up in, everything, what I thought was fun and what I thought was what I wanted.
My uncle did that, was one of those water witches, whatever they call them.
Dude, it's legit. Totally legitimate. I worked with this guy, not together with him, but alongside him on many jobs where they were setting up new construction. Out here where we live, if you're not in city limits, you have to get somebody to come locate and dig you a well or whatever, or drill it, or whatever the technique is. And he was like the all-in-one man. He went out there, he dials the location, scratches, spotting the X in the sand with his dirt or whatever with the heel of his boot, right? And he had on the back of his truck drill. It wasn't a drill. It was a punching device. It used gravity, right? It was hooked to the back of his F-350 one-ton pickup, and that some bitch would pick up, slowly pick it up and then drop it down. It was just a spike, basically.
Gravity.
And then from gravity, yeah, whatever you want to call it, whatever causes that thing to fall to the dirt. Yeah, he used that. And he went ahead and installed the case pipe, the drop pipe with the foot valve on it. He would come back and plumb back to the pump, and he'd do all but the electrical. And he'd run it to the house, the main whatever it is, hook up. And
I got a question. When it comes to picking where you start digging your well, like, why is it that one place is better than the other? I imagine there's some sort of underground, like, stream happening, and you need to.
Aquifer.
But
Yeah, it's
like
aquifer system.
but those are like veins, right? So anywhere along the underwater aquifer is fine. So it isn't just one spot in a backyard. It's like a line, more so, right? And anywhere along that line is viable.
Intersection of lines.
Well,
Yeah,
he,
where you
like
I
an
didn't
intersection.
ask. I sure wish I could have asked him these questions, man. Hindsight, but
you can
I
follow.
don't know.
Yeah, you walk over a flow, and you can get a linear look, and you can probably triangulate and whatever. But probably more for access, or where do you want to put your well? Here's where a vein is. Yeah, that's my answer. I don't know. Less experience.
Well, if someone has knowledge and that's willing to share, I sure would be interested in it. Or experience with it,
But he didn't do electrical.
No, he didn't do the electrical, but he knew electrical. As a matter of fact, he helped out on a service call I went to. It was a water source heat pump, and it wasn't getting the water going through the water source heat, the tube and tube heat exchanger, right? Where the refrigerant line goes inside of the water line, and that exchanges the heat instead of air, right? Anyway, the I did it. I tested for the electrical, and the pump didn't have the 240 volts, but the signal coming from my water cooled heat pump was sending a signal for it to be on. So I told the customer to call electrician. Electrician said, "Oh, it's got power." I said, "No, it doesn't." Anyway, she said, "I'll call the well man or the pump man or whatever." And it was John T. McNeese. It was that fella. He came out. He broke out his damn equipment. He he scratched a spot in the sand with his heel of his boot and handed the electrician a shovel. And he dug down just a little bit, and sure enough, tink. And what it was a junction box that somebody had put in underground that had a relay that didn't even be in there that had gone bad. And the electrician, anyway, it was that right there was a demonstration, along with other things to me, to remove all doubt that something is going on there.
What's your take on ley lines? Before you answer, it seems like all the people who make videos in ley lines all have like a different arrangement of them on a globe model, a flat model, based on just whatever they feel like base them on. I don't doubt the existence of like energetic channels, but there's so many people with different diagrams laying them out across the face of the earth. It's like, well,
Yeah, but
that just means that most of you are just pulling this out of thin air and don't even know what you're talking about.
no, but isn't it structures and dams and bodies of water and rivers? Just kind of the projection. What map you put
That's
out? Go ahead.
Yeah, exactly. The projection comes into play. A lot of people say, "Oh, my ley lines are just based on connecting ancient historical sites with each other. Let me just connect Stonehenge to Washington D.C. and call it a ley line because I don't know, Paris is intersected between that, and so that works for me. I don't know. I don't take most of the
Well,
people who believe in them very seriously.
yeah, have you heard of star forts, for example? Kind of a
Yeah,
mud,
yeah.
mud
Yeah. All over the place.
yeah, and then like what water was in places, and I haven't watched a lot of Michelle Gibson, who may be someone who mapped a lot of that, but I've seen the topic come up, people that aren't even trying to talk about it. So
I love the
Starfleet.
idea.
Well,
I love the idea that ancient structures were built in precise locations uh, because they were tapping into nodal points with some sort of energetic sort of matrix covering the Earth or whatever. But yeah, no one's ever seems to go into detail of explaining like the epistemology behind their theory. Not in any convincing way, it seems like to me.
go ahead, but yeah, the Golden Gate, Silver Gate, the big fire right by the St. Louis, right? Yeah, it's I don't know what how you're trying to define what a ley line is and how it forms or why it's there. Yeah, a lot of
What I heard was a question on what's your take on it.
Yeah.
I don't really have a take. Like you, I've seen different claims and whatnot, in the teachings and my awareness, whatever. I haven't heard stuff referred to as ley lines. Now I'm familiar with stuff like telluric currents. I'm not
I
sure
think
if
that's I think that's related. What's your how do you define that telluric currents?
telluric currents is. I first learned about it in astronomy because it affected what we perceive allegedly at the time. So it was taught. But telluric currents are both accompanying magnetic and also non-accompanying magnetic. Um, it has something to do with what I call our solar circuit. We have cycles, solar cycles within greater cycles. We know and familiar with the 11-year solar cycle, which we're at the height of at the moment for the rest of the year, and what we call the Carrington event, where a lot of electrical grid in Canada got knocked out, or a portion of it. But more amazingly, the batteries blasted out. They come up in the wires with sparks flying off of them, come out the ground, the telegraph, and then other places they removed the batteries, but the telegraph still worked. This is what I mean by telluric currents.
Yes, Wikipedia says an electrical current that flows underground or through the sea resulting from natural or human induced causes. These currents have extremely low frequency and traverse large areas near or at Earth's surface. Okay.
ELF, definitely. Extra low frequency or extremely low frequency.
Earth's crust and mantle are host to telluric currents with around 32 mechanisms generating them, primarily geomagnetically induced currents caused by changes in Earth's magnetic field due to solar wind interactions with the magnetosphere or solar radiation effects on the ionosphere. Oh
You
yeah,
got
that's
it,
really
bro.
interesting.
Yep. See, that's cool that you asked the question and we were able to reciprocate knowledge. That was cool.
Yeah,
Both
after I
telluric and magnetotelluric methods exploit these currents for subsurface exploration, aiding in activities like geothermal and mineral exploration, petroleum prospecting, fault zone mapping, groundwater assessment,
Water.
and the
There you
study of
go.
tectonic
Water.
plate boundaries. Yeah,
Mm-hmm. You got it.
okay. I'll definitely
And
look into this.
well, yeah. I mean, I was very fortunate to be able to access the knowledge and information I was at the time that I was, and I recognize that's not a normal thing, but I thought it was at the time. Yeah, I didn't know any better. I'm so glad I was interested in what I was, and I should have been way more interested in this stuff, and learned a lot more. But I didn't recognize its value because it wasn't being valued, if you know what I mean.
Yeah, I get you. And this is kind of interesting. It says in fictional references in the 1988 Foucault's Pendulum novel, it revolves around a conspiracy theorist. All right, oh, my ears popped up. Conspiracy theorists who believe that they are searching for the umbilicus mundi, the navel of the world. The mystic center of the earth, which is supposed to be a certain point from where a person could control the energies and shapes of the earth, thus reforming it at will. Shapes of the earth. I don't even know what that means.
Um, the form, the function, and that's that. You're getting into the tales or the mythos, and
Yeah.
that are tied with it. And different cultures have different takes and perspectives of similar things.
So I just posted this video to further explain how a gyroscope keeps its rigidity in space. 1 minute long for anybody that's interested.
Yeah, a minute. I don't think I got a minute.
I was gonna say, dude, I can try to pretend if you want me to. Okay, give me a second. Alright, it's the difference between interplanetary space, interstellar space, and intergalactic space. You must specify, sir.
Yeah, good video. See, how would you put in your own words, like why a gyroscope or really just a spinning wheel, resists, well, persists, I guess, really.
That's a good question, bro. I wouldn't know where to begin. I mean, that's what it does. That's
Angular
the function
momentum.
of a spinning wheel. It's crazy, but
Conservation.
Well,
Angular
I think
momentum
it,
always follows torque. That's the simplest one I can express to you, and you can play with it, and you'll find it. You'll see it.
yeah, but he said
here,
why? He said why?
yeah,
Oh, why
here's,
does angular momentum always follow torque? I don't
Like,
know. It just
well,
does like
I'm
that.
not talking about angular momentum and torque. I'm asking why a spinning wheel will persist.
I'll fight
Is
back.
keeping its rigidity in space. And here's my, put it my own words, answer. Se is because it's a wheel. Uh, it's a wheel in motion, and that means that, uh, in the sense of opposite forces canceling each other out, if you push one side of it one way, then that has to result in the opposite side getting moved the opposite direction. And so you're not just pushing one side of it one way when you rotate it, or when you attempt to rotate it, you're pushing the other side the opposite direction. And so it's going to resist itself, since you're asking one side to go one way at the same time you're asking the other side to go the opposite way. And so it's going to cancel itself out.
Planar centrifugal motion.
Yeah, well, it's always like an equilibrium, and you're trying to mess with that. So
Yeah, let the other person go. What were you saying?
So I just said
Was it
planar
angling?
motion was the most concise thing I could come up with, but I don't know how accurate it is.
Say it again, because I interrupted you 2 times, I believe. What did
So
you
good.
say?
Planar centrifugal motion.
Planar centrifugal motion. Okay.
I just made it up basically because you guys were asking what was the best way to describe that. Because it maintains a plane, a particular plane of orientation in reference to the lab frame, of course.
yeah, we want to know why.
Yeah, just
I
simple.
think like real related is like when I was a kid, I lived on a real long straight street, and so we would pedal our bikes, and then we'd jump off the back of them and send them rolling down the street, and we'd see who'd get their bike to go the longest before it fell over. And they'd always make it to the end of the street unless they hit a curb or something. And like those bicycle tires in motion are gyroscopes themselves. That's why a bike, it's the same reason why a top doesn't fall over if it's spinning. Obviously, a top falls over like a spinning top. If it isn't spinning, you put it's on one single point, it just topples over. You spin it, but when it's something's in rotation, for part of it that would want to be angled at the ground, that means that the other side of the top is angled upward and trying to send it upward. So the part that gets thrown down has an equal and opposite counterpart on the other side that's angled upward trying to shoot it up. And so it's just going to find balance, because like a wheel in motion is just going to cancel out the opposite ends, like, and what they're trying to achieve, and they're going to have to come to a happy medium and like get along with each other.
Another thing it does, which is not often talked about, it seems to get lighter. You ever see one? They spin a wheel and you could just lift it with one hand and just whoop it around while it's spinning.
Yeah, it's not actually physically getting lighter. Uh, it's just like if you ever tried to lift like a heavy sword by the handle, right? It's like, oh man, I can't do this. But when you put the spinning weight on the end, it basically makes it the equivalent of lifting that heavy sword from the center instead of trying to lift it from one end. It's weird how that works, but yeah, it's not actually getting lighter. It just kind of uh, redistributes the way the forces of weight are pushing down and up, and we all know that lifting something by the end is a lot harder than lifting something from the center.
Stable.
But another thing about lifting that spinning gyro weight on the end of a bar, right? You have to keep spinning around to the point where you're standing on. You can't just spin the weight on the end and lift it and just stay still. You have to spin in place as you lift it. Like you have to step in a circle, kind of, or rotate your body as you're carrying it.
Well, and there is a magnetic field, right? Not a lot of anti-gravity, but
So
Man,
that's how they build
if
the
you've been
pyramid.
if you like my study in the gravity and all is it keeps taking me back to Huntsville, Alabama, and just so happened, guess what's headquartered there now? You know, like if you look into Dr. Lee and what happened to her after she made this breakthrough and whatnot, and I forget the young lady's name, and she just happened to have a freak passing away, if you will. But yeah, there's a lot of stuff that's been happening there as far as anti-gravitics for a long time, and but yeah, I got way more questions than knowledge on it, man. I just maybe someone in here is aware of that.
There's this Scottish guy that claims he built an anti-gravity machine using gyroscopes. You ever hear of that guy? Way back from the 70s.
Nah, do tell.
I think I've seen videos of
I
special
posted
spinning.
some before. I don't know if I still have that video, but you can Google it. Google Scottish guy anti-gravity gyroscope machine. And you see the thing rising up now. I don't know if it's real or not, but you
Counter-rotating.
actually, yeah. I'll try to find it.
I was just, kind of mentioning slightly on the effect of lifting a gyro center of gravity or whatever.
Well, like when you add charge to it. My bad, my family's loud.
It's all background.
You got the whole family over.
Well, yeah, and they're usually happy and loud.
Well, that's a good thing.
Agreed. I'd much rather be happy.
This might sound oversimplified, but it seems to me that the secrets of levitation technology or whatever would definitely be rooted in electromagnetism and something spinning at incredibly fast speeds.
Correct. That's
I
part
almost
of what I found demonstrated. There's a fella, Brown Townsend, Thomas Townsend Brown. anyway, people made fun of him because he dedicated almost all his life to it, and and I followed it. I was able to follow his work right up until he added electricity, and then rotation, and that's that trail kind of went
Ele-
cold.
High speed pulsing, high speed rotation, electromagnetism, and then some sort of very magical geometric arrangement of different parts, and then the final ingredient would be some sort of material science. It's like, are there foreign materials that are kept secret from us that are the key to all these questions?
Close.
Did they keep the
No.
cool? Do they keep the element 125 away from us?
Well,
But
I
So we
think you're
found
referring
element
to
125 at the outer pond.
137. And anyway, let's see, 115. That was Moscovium. That was
Isn't
Bob
that the
Lazar
thing
product.
that Bob
And
Lazar,
yeah.
exactly.
Well, anyway, it was they're called discovered or manufactured later, officially as Moscovium, but they don't allegedly don't have a stable isotope yet. Allegedly, but as far as that goes, man, when I was young and I was like, why don't you move over a couple spots on this here elemental chart and use this instead of uranium? And the answer was, well, because of the byproduct. I'm like, oh,
The
I
one
get it now. The byproduct
one
and what
thing I
it's
learned
used for.
from oh, sorry, bro.
No, I'm finished. It was just a byproduct and what it's used for. That's why they go with that.
One thing I learned from the old school Tartaria videos uploaded on YouTube is that radioactive materials, whether I forget whether it was plutonium or uranium or whatever,
Radium.
is well, maybe that's the one they made videos on, but all in
Madame
that
Curie.
basket. What I learned is that they used to be common products found in consumer goods, like warm socks for the winter, things used in different fireplace applications, hot packs, and all sorts of things. They were used, and then the radiation scare propaganda stuff came in, and it got removed from the marketplace. And I could tell you the two sort of scares. One of them was these girls who would do performances with face painting, who grew tumors. That was used as a big prop. I won't go into detail about it, but it got removed from the shelves, and that might have set us back real far, that they took away this really incredible thing for us to explore and work with. Now it's a restricted material that you're not allowed to have anymore.
Yeah, the watch, the glowing watch hands that were painted by hand. They licked the brushes and stuff. So,
Slightly radioactive. No big deal,
but
right?
then they ended up living long lives. Like maybe they lost some hair and mercury. Anyway,
You're talking about electrogravitics and stuff, and it's funny in that like the alleged release documents from the CIA or whatever, the TR3B, the flying triangle, they actually state in there that it's electrostatics that they use. And so I don't think it's necessarily some super complex thing. It's actually really simple, just field pressure mediation. And they're working, with an ether field. You could call it an electrostatic field, but I guess I say all that to say everything always leads you back to the ether. Ether and field pressure mediation.
All right, Ken Wheeler, I hear you.
Pretty simple.
or yeah, it's the thing is, it's like a gyro, 3D gyro. It's always like stable.
Manipulating the field, You create more pressure behind you and less pressure in front of you. And if you've ever seen these things move, like I've been lucky enough, I've seen one in broad daylight before. I've seen multiple UFOs. They move really creepy like. It looks like something moving within a pressure field. That
Well, that's
explains why they
even
can omnidirectionally too.
well. That's
But
even
I
how
feel
and
I,
birds move.
I it seems like the archetype of science here is learning how to swim in different types of medium. You know,
Well,
like like if we were at the bottom of the ocean and we had gills or whatever, but like we weren't buoyant, right? Like we were made out of stone, or that we sunk like a hammer. We'd invent some technology there. We'd realize, oh, we can do some sort of turbine sort of thing. We can learn how to, even though we're heavier than the water, we can learn how to swim through it. Then we'd get up to the land. We'd, break through the sea level, right? We'd find ourselves in air and be like, oh man, we can't fly anymore. We only have technology that is designed to propel us to swim through water. But then we'd figure out airplanes and helicopters and drones sort of stuff. And be like, oh, we can swim through the air now. Obviously, we call that flying, but still, it's all swimming at the end of the day. And then the next evolution past that is like, how do we swim through something even thinner than air? Obviously, jet engines aren't going to do the trick if there's no air to swim through. Not that we're trying to go to a place without air, but if the ether is amongst us, how do we design devices that can swim through the ether? What do you need to use to push off of the electromagnetic field as you would push off of air or water with those more primitive, uh, engines?
the same reason a bubble rises to the surface in water, but you're able to manipulate the direction of your, rising to the surface, if you will. Like lightning, lightning equilibrium with the ground, So there's obviously this directionality to not only gravity, but also this field pressure.
Well, the bubble thing, that's an interesting thing for you to bring up, because obviously a bubble rises by having like a pocket of less dense medium surrounded by a more dense medium, but I don't think that technique alone, gets where we're trying to go, because I don't think you're going to invent something, thinner than the ether, right? And so it may need to rely more on the approach of, a solid chunk of aluminum, like an airplane flying through something less dense than it, through, was the Bernoulli principle, lift and all that stuff. You know what I mean? Like, it may not work like a bubble. It may have to work more like an airplane. Oh, but I don't know. I don't freaking know.
A magnet would be the closest one-to-one, but it wouldn't be the magnetic field, I don't think, that you'd be working with. But the same principle, I think, would apply. It would be a field pressure mediation. Magnet really is perfect, because it's really mysterious to us. We've all seen a magnet and played with it before, and it's like,
Yeah, it's not attraction. It's like organization of flow. Or
Ken Wheeler's latest description is actually pretty good. It's trying to erase the space in between.
yeah, but I mean, even our airplanes are like pulled through the air. Think about it.
Right. So there, there's the helicopter airplane approach, and then there's the bubble approach. And obviously the bubble approach is more like, blimps can stay in the air longer using less consumed energy, right? So that's obviously the more efficient mode of transportation, even if it's less speedy, it takes less effort, because a rubber ducky doesn't need an engine to float on the top of water.
Right, and then
So that would,
you hit the jet stream, and you're like, "Hey, I'm floating on a river." Like highways up there. That's really what happened. But
I guess it's really similar to asking, like, if you were underwater, how do you create what technology would an Atlantis Gill, having humanoid civilization, how would they make a pocket, like a vacuum filled bubble while being underwater? They can't draw air from above the water downward to them to make the bubble. They have to literally separate the water amongst itself, divide the water from the water, right? And seal it off inside of some sort of bubble vessel. It's like, well, how do you make a pocket inside of the ether? Because the only thing that could be less dense than the ether would be the absence of ether. If you catch my drift.
Well, a magnet is like an ether polarization device. So essentially, that's what you're talking about, is any toroidal field, basically. I mean, you think of like less pressure or something like that. So like the hole in the center of the donut, might
Right.
be what you're talking about.
Yeah. How do you create that? How do you create that absence of magnetism that's found at the center of every magnet without the lump of hematite or neodymium or whatever? How do you make the field without the material associated with it?
Well,
You see what I'm saying? Like, how
like
do
an
you make a magnetic
inversion.
field without a physical magnet being present?
You make
Well,
an
I
Like,
mean,
electromagnet. I don't know if that would count.
like the torus has has lines of the centripetal and centrifugal. It's kind of separated. You have plane of inertia. You have like lines finding something. Anyway, what were you saying? Like
The problem with
after the
magnetic
flying.
fields and using them is that they're always attached to a physical magnet.
No, but
How do
you're
you get
saying
one without the other?
after flying it gets thinner. I think maybe at some point it's thick again. Line hurting.
The answer may be fundamentally rooted in light. We, I maybe I mean, Ken Wheeler claims he has this figured out, but they call light electromagnetic radiation. But what really is the relationship of a magnet to light? Can you create like a magnetic like no, like the same way a magnet will pull iron, like nails, iron nails, right? A magnet will pull iron nails to both sides of it. Now, how do you create that same phenomena in the middle of thin air without a magnet? Like, to me, like, can you, like, I don't know, shine lasers at each other, crisscrossing in some sort of weird way, where even though there's no magnet there, iron nails are still attracted to this spot just in the middle of thin air? Can you create
Oh,
like a magnetic attraction in thin air without the actual, a neodymium lump of mass or a hematite lump
Electromagnet.
of mass actually being there?
That's the only one I can think of is electromagnet.
Which still requires like a metal coil.
what about ball lightning? Plasma phenomenon of some kind.
That's that high potential there. Yeah.
I saw one of those in real life. Real up close as far as those sightings go.
Oh, dude, tell that's crazy.
Oh yeah, dude. I was hunting. That's the reason why I saw it. It was really early in the morning. It was in November. And I was in my stand an hour before daylight, like I was supposed to be. And I was just sitting there for like 15 minutes, and then just super clear night. The moon was really bright. Just like off, I started noticing this. It's just a bright plasma orb. Looks just like a spirit bomb from Dragon Ball Z, and it's perfectly silent. And it's probably like
Okay.
2,000 feet off the ground. It like wasn't very far off the ground at all. And it was so freaking bright. It was crazy. And it just perfectly motionless, or it was moving perfectly silent. And just slowly moved, and I just kept watching it. I got to see it for like 2 full minutes probably as it slowly moved and just kept on going. No more than like 3/4 of a mile off the ground.
Man, just like you brought up Dragon Ball Z, wouldn't the craziest revelation be that these things can be created through like conscious attention, like directing your will and directing energy like consciously? Like, man, because
It
I
sounds
mean,
like you're speaking of the old tales of the Kachinas.
so
Almost.
what?
The Kachinas.
Is that a tribe or something? What the hell is that?
No, it's the phenomenon of the different, I guess what we would call today orbs or whatever, and of different colors. And the different colors had meaning. It indicated whether they were mean or not.
Well, I'll look into that.
Yeah, I
But
believe it's K-A China, as far as spelling, if I recall correctly.
okay, okay. Yeah, I'm sure. I'm sure. Like 20 years ago, or sometime since then, we've all seen the documentary where like the European guy goes to interview this like energetic healing master, and uh, it's really worth a rewatch. I watched it recently. It was even better than I remembered it as during my childhood. And it ends with him lighting a piece of paper on fire with his hand just pointed towards it out on the sidewalk. You guys remember that one?
Nope.
Oh man, that's definitely worth a watch. I might have to
Just
link that for you guys.
I linked it and tagged you just now.
Oh yeah, I saw it.
Cool.
Thank you. What a cool video. Obviously anything can be faked on video, but I'd really like to believe that it's legit. And if this guy knows how to set paper on fire just through directing, as he would say, his chi, then that possibility just opens so many doors of potential where it's like, oh man, what else is achievable if humans learn to harness these latent abilities that they have of directing their energy through conscious willpower and stuff.
Different cultures have different names for the same thing. Some close by are ki, like in Japan and Korea.
Ki,
Then you have
chi,
mana and prana. Then people that followed the work of Wilhelm Reich, orgone.
orgone.
Yeah.
Yeah, for sure. Vril.
Yep, Vril. But yeah, it
Mana
depends on the culture and and the time.
Mana Prana, Vril, Chi, Ki. Yeah, I love it. Yeah, they're
Yep.
and at the end of the day, it's all ether electromagnetism, or that that's just another. Add that to the list. It's all the same stuff.
Yeah, dude, the key takeaways from that video there, for me anyway, I've been watching it again for sure. It is great. He said that the ratio between yin chi and yang chi is what makes and creates different effects. So he talks about that a little bit, and then he also said that you'll go through the whole story. He goes back into the jungle for a while after he has the ordeal with the people where he draws blood. And then he comes back out to give a message to say that he wants to tell people that he's not special or anything, that everybody is capable of doing this,
Yeah.
through meditation.
Yeah, I would say that there some of us are more apt or aptitude. Everyone's different, and also different fingerprints and scars from our previous experiences that might prevent us from allowing ourselves to be. Yeah.
Dude, the thing the thing that I want to highlight the most is that these ancient, theories of a omnipresent field of energy that is responsible for all uh, actions in the world, and that is the same force involved in animating all of our living flesh, right? Like this was an idea so back in the day. This chi, ki, vrana, mana, prana stuff that is it's everywhere, and it also flows through you, and it's what animates all life. Well, that 100% matches with, even mainstream Western or I get worldwide at this point, the concept of electromagnetism or electricity. Is what animates all your muscles to move and all your thoughts to translate to the rest of your body through your nerve system, not electromagnetic impulses? Are we not involved in a one big soup of an omnipresent electromagnetic field? They were spot on. They had a different word for it, but the big claims that they gave to Chi, all this stuff, right? Oregon, if you want to throw that in, that is exactly the same qualities we ascribe to electromagnetism today. So, I just want to say, flowers to them. They were right. The same thing that animates our bodies is the same thing that basically is at the source of all causes in the world. Even if you ask scientists about like, why does matter interact? They'll say, well, nothing actually touches. It's all interactions of electron orbital fields magnetically repelling matter from other matter. And why does any chemical reaction occur? Oh, it's because they're swapping electrons, creating
Right.
chemical
Their
reactions.
spin
So
rate. Yeah.
yeah, it's all the same thing that people have always been saying, and maybe we shouldn't get so caught up in the limitations of the current description of it, and
The
have a bit more faith.
compartmentalization has gotten the terminology and phraseology mixed up to where it makes it damn near impossible to communicate with someone unless you sit down and go over what each fucking word actually means to this individual. Like me trying to talk to a chemist buddy of mine. We had to sit down and cuss and discuss for me to use the phrase angular momentum because rotation speed, spin rate, spin speed, all that had different meanings in chemistry, right? And positive meant negative in some situations, and all kinds of crazy shit we had to work through just because of the compartmentalization that has taken place. And he said within
Hmm.
chemistry, it's compartmentalized as well. There's different compartments of chemistry. There's even theoretical chemistry, and he himself admits that chemistry is based on theory anyway. And why? Because it's a framework that works at a certain scale, within a certain scale.
Yeah, yeah. The phraseology. I appreciate you using that word. I haven't heard that in a while. The phraseology of it all, and the definitions are all revolved around what has been discovered so far. And that kind of language, while useful for taking record of, being able to describe what they've accomplished so far, it closes off the doors of what it potentially could be utilized to achieve in the future. And you can't read into it because the definitions and the words and the way they recommend you use these words are only meant to describe what's been discovered so far of what works. And it's not at all angled at what potentialities they might be applied to in the future. So we might need to take a page out of, I don't know, some mythology from the past or something to really point us in the direction of what's possible if we learn all its secrets.
Well, there's a reason, there's a source for a lot of what we call fiction and mythos and whatnot. And it usually lies in something legitimate. It was just the perspective of who was present and how it got passed down. It might not be recognizable for what it is today, especially from someone that has no clue what they're looking at.
I've never read those Hindu texts. Maybe it's the Bhagavad Gita, or maybe that's just one part of a larger text. But you guys have probably heard about what kind of crazy science fiction stuff gets described in those holy texts. Of like battles in the sky and all sorts of crazy stuff, and like
The Vedas.
yeah, exactly. It's like maybe that's less fictional than most people think.
Yeah, because it's not just them.
The-
All over the world, they have these what it's called tales, right? Because it must be fiction of being visitors from the sky. Uh, yeah, it's pretty much an echo, like of familiarity going through the different ones. It's yeah, I don't know what to think of it. I just recognize the similarities.
You mean the red triangles versus the blue cigars shot over Germany? Those old drawings for days.
Yeah, that was something my great grandpa did share with me was knowledge and tradition was passed down through art and entertainment, song and
Well,
dance.
what the heck ever were Foo Fighters? Isn't that something that none of like you've heard of those, right? Foo
Yeah,
Fighters, like weird, mysterious flying craft. What during the Vietnam War was it, or
World
World
War
War
Two
One?
mainly. Well, it was mainly
Yeah,
World War Two, but um, it yeah. I mean, we thought it was them. They thought it was us. And that whole story that happens that recurs.
let's see. Okay, I just googled it. This is straight from probably pulling
The
from Wikipedia.
Fighters of the
What
Foo.
were Foo Fighters? It says it was a term used by Allied pilots during World War II for unexplained aerial phenomena such as glowing fiery lights that appeared in the sky. Yeah, like what? Like, how is that Google's best answer? It isn't even trying to sell me on some sort of propaganda. It's just being straight up like, yeah, weird fiery unexplained lights in the sky during wartime. It's not even saying, oh, it was some German or Japanese or Chinese. It's like we don't freaking know, dude. It's like, how do we not know?
Yep, and another culture would say that's red kachina, and be glad it's not a blue meanie.
I'm not. I, I I stay away from UFO research just because the waters have been muddied so hardcore. If you try to research into it, you're just gonna uh, you know, can you're just gonna come across a bunch of shit that people just make up. It's like that's unfortunate. I wish someone had like a document for me of all the someone who's dedicated their life to sorting the wheat from the chaff or whatever when it comes to UFO research. But unfortunately, it's up to each one of us to just use our discernment. But what a waste of time that is to have to wade through the bog of all the BS.
Let's see. When I was a young, there was a dude. He was NASA, physicist, blah 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 blah. Anyway, his name's Stanton Friedman, and in his early work, he put together Probably one of the best presentations I've ever seen. It was available on VHS, and I ordered it and watched it, and then I went and double checked all those claims and all, and it's all legit. But
What did you
that
say
was
his name was?
Stanton
Stan Friedman.
Friedman. Yeah,
Okay.
FRIEDMAN, I believe. It might be
What's his
FRE.
what's his background? Is he like
He
an
was
insider?
yeah, NASA. He was a physicist. He invented waste heat recovery, which I used in my field as well. Waste heat recovery, and then it kind of vanished. It came out of style, even though it increased efficiency of shit tremendously. It's a shame it's disappeared. Well, it hasn't totally disappeared, but it's not common anymore.
Waste heat recovery. What's that? Just about like using something's waste products to power another machine?
Oh yeah, like say using the heat that's coming off the condenser of an air conditioner to heat your water in your water tank, as opposed to your element, because you're already moving the heat out of your home and it's going somewhere through the process of refrigeration. So
So that's just a study of just like efficiency and like I guess I would call it like energetic recycling, or
yes,
or basically just being smart.
exactly. But yeah, if it wasn't for the experiences I've had in my careers, yeah, I would be clueless on this. It's one thing to study something in books, but when you get out there in the real world and you see ain't nothing like it is in the books, you're not in a controlled environment when you're in the field. Everything's always different depending on where you're at, when you're there, etc., etc. That's when you really get to learn.
You ever seen those videos of electric vehicles existing in like 1890, something like that?
Yeah, they did.
I even Googled it one time because someone made this claim in a video that like before the Model T, it was like 80% of vehicles were electric
Dude,
before we switched to fossil fuel powered. And it's like, whoa, what? 80%? We had everyone who had a car, which I'm not saying was a bunch of people,
no, it wasn't.
but still, out of the people who did have cars, 80% of them at one point were battery, electric vehicles. That's just something they don't tell you in school.
Yeah, yeah. It's grotesquely incomplete or just false. Most of what I was taught in school.
I think there was even this video that they showed in in the YouTube clip I watched where it was demonstrating like, oh, this guy pulls up in his electric car because his battery's running low, and they just popped the old one out that was drained and popped in a fully charged one, and he was on his way. And wow, that's even faster than a gas pump. Just pop in, pop out, boom, ready to go.
Yeah, there was no charging station. You didn't have to stop and park your car and wait for a day or whatever. It wasn't just that, dude. We had steam as well,
Steam.
and
I mean, Is
We
steam
have.
really that great of a technology, though?
Oh
I mean, you
fuck
gotta
yeah.
burn. And what you gotta burn coal or wood or something. I mean,
No, you
you
don't got
could
to burn
argue
a
that
damn thing.
wood is a renewable resource as long as you're planting new trees, but
You don't have to burn
it's
anything
for
to heat
steam.
water.
Oh, I
Yes.
mean, what are you using, like radioactive rocks?
Well, dude, I guess it wouldn't matter what the hell you're using to heat the water. We could be using the geothermal heat to steam, create your steam. It depends on how you want it set up. If you want to get advanced, you get evacuated glass tube tech lined with luminoid, where water heater, where on a cold winter day, on overcast, it's still forming enough heat to where it's boiling the water in the tank. There's many different solutions, right? Some more practical than others, and depending on where you're located too. Different situations. What works here is not going to work there. Different conditions, parameters, and variables.
Yeah, I feel like an underutilization of technology already at its disposal is just taking advantage of the the heat that everything can receive during the daylight time, and the fact that things will cool off and basically charge them, like things will condense, they'll cool off, because usually heat makes things expand, and then things naturally give off heat and will cool off and condense and shrink, at night. And it's like, shouldn't shouldn't as much of technology out there as possible be designed to basically run off of the fact that the sun will heat them up and make them expand, the water and the steam during the day, and that if it's a closed system, there's no loss. It's all solar powered because during the night, the steam will recondense into water inside of a sealed chamber and be ready to receive sunlight and heat up and evaporate the next day.
Yeah, and well, that's forbidden. Basically, what you're saying, though. I mean, you can look it and find it. You can use an LLM, and they'll tell you. See things that one's been
If you
dropped, others
if you
may.
just had like a if you just had like a giant glass like pool of water with like an elastic sort of balloon over the top of it, if you just had like some magnifying glasses, some mirrors, some refractive lenses or whatever aimed at it, during the day there's a balloon over the top of it, right? It'll expand the balloon, fill it with steam, the water evaporates, it fills more volume, the balloon expands, and then at night, well, the sun's gone, the light's gone, it'll cool off, and then the balloon will shrink and repressurize, or the opposite, I suppose. And it's like, well, isn't that a very simple solar paneled like pump of sorts?
Oh,
Just a sealed
definitely.
container, just a
A
balloon
diaphragm.
with water.
You could have a diaphragm that would actually pump. It would be slow, but it could work that way. You could,
You can put them in parallel. You can have as many as you want. And that's primitive solar tech right there. I
well,
don't even
not to
know how
mention
these modern solar panels
solar.
work.
Like, if you're in a situation where you need to use solar distillation, what you're talking about would definitely fucking do it, because you catch the water as it evaporates, and it leaves the particulates in behind, and you get your trough off the hood catching the steam, right? And it would pour into a container, and then you could do it again, right? But anyway, yeah, there's so many things that can be utilized, that a lot of people would benefit from this knowledge, especially uh, in certain situations.
In a perfect world, it'd all be about striking the balance of, like for example, like when dealing with a car, you could attach all these apparati, whatever, to it, but then you got to consider the weight, of all these. How you put it? What do you say? What was that word you used? Heat capturing. What was that field you were talking about?
It's called waste heat recovery.
Waste heat recovery, right? And when it comes to a car that needs to move, it's like, all right, you could strap all these different apparatuses to it to make sure you make the most out of it. But then every new, module you attach adds weight to the car. So there'd be a balance you'd have to strike where it's like, all right,
Oh yeah,
I gotta give up this.
modern or modern, what we call today modern. We have brake charging, right, for the electric vehicle. But that's only during braking, right? And anyway, yeah, I have a bunch of ideas on how to improve that shit, but I'm not really a big fan of the electric vehicle as is because it doesn't have a conventional battery. It's got some shit that we got to destroy the Earth. I thought it was about the fucking planet, guys. I thought it was about the environment.
Nah.
What the
Hey, but
fuck?
you must know about flywheels though, right?
Oh yeah. Well, I had to. That's
Let,
part of the shit. Yeah, that's part of
let
it.
me ask you, do all cars have flywheels?
In a manner, one way or another.
And are flywheels in most cars literally just like a lump of iron, just like a heavy wheel that retains the momentum so it can be
That's it.
stored and
You got it.
what
It's stored. You got it. You
I've
got it,
never
dude.
where the heck do I find that? And let's just say by Honda Civic or something. Does my Honda Civic have this flywheel in it? I've never seen it. I can't pop the hood and find the flywheel.
I think it would be attached to, if it's automatic, it would be attached to what's called a torque converter.
Okay. And its job, right, is to like, your car's it's gonna speed up, then it's coming to stop. And instead of having your car start from scratch, get the wheels turning again, when you come to a stop, you got this flywheel rotating within it, and to retain some momentum, so that when it's time to go again, when the light turns green, it can borrow from the energy that's already stored up in it.
Yep.
Yeah, that's cool.
It depends on the driver, and if it's automatic or if it's a manual, and yeah, do they know how to drive? Like you can take the same fucking vehicle and put somebody behind the wheel, and then you take the same vehicle and put a different person behind the wheel and get a completely different performance out of the same damn vehicle in the same day. I've seen it happen. It's just, and music, as a musician, the same guitar playing the same song, pass it to the next guitarist, and it's gonna sound different, you know. So a lot of it is up to the operator.
There was a guy on here a few months back that showed me all sorts of videos about uh, hydrogen cells, and he showed me this dope video of a guy who like converted his car, and he did it just to prove, like, he had this idea, like, hypothetically, and everyone made fun of him, and so he went ahead and just rigged his whole house and his car and all of that, and just did it all himself to prove that, screw you for laughing at me. Now I'm off the grid. I run everything I own basically off of water. It's super
Well,
efficient.
yeah, and the exhaust is water, and all right, his name was Rudolf Gunnerman back in late 80s or 90, 91. Anyway, he had already obtained several patents because he worked in the petro industry, right? he was removing sulfides and whatnot from the. Anyway, he had this. Go ahead.
No, you go ahead. Thank you.
Okay, he was running about a 50-50 water fuel mixture, and demonstrated on a bus in L.A. Actual demonstration. They did the exhaust test on it. It's the cleanest they've ever tested by far. But it comes back to the same thing. It's like, when is this going to be available to the public? Well, we don't know, because it's a matter of national security. And it comes back with the other dude that you're talking about. And the same question was the same answer. And like the nitinol machines, when they were demonstrated back in the late 80s, their answer was the same thing. When is this going to be available to the public? Well, it's a matter of national security. And it is.
I got something.
It is.
I got something to add on, but I think that other guy should go before me if he had something to say. What's up, other guy? Who was that? All right. Well, if he's not going to go, one of the really cool things about the guy. I mean, of course, fundamentally, it does come down. This video, I could track it down. I know exactly where to find it. Because I sent it to my dad, because my dad, when I was a kid, he told me about the guy who designed the guy with the car with the engine that runs off of water who got killed. He showed that to me real early on in life, and so I knew he'd get a kick out of this guy who does something kind of similar. But the thing is, the video I sent my father, he still has to perform electrolysis on the water, right? And so obviously his electrolysis machine doesn't run off of water. He still relies on the grid or a generator, fossil fuel stuff to run the machine. But still, to him, it's a benefit of providing him an off-grid lifestyle because of something really cool he mentioned. He says hydrogen doesn't deteriorate. The hydrogen fuel cells, you can come back and I can have he can have like propane tanks, but, filled with hydrogen gas instead. He's like, in a million years, I can come back to these and there's still hydrogen in its exact usable state. You try to store gasoline or whatever, right, in a tank, it goes bad. But if you store your energy in hydrogen, it's good to go in 10, 20, 100,000 years in the future. Because at the end of the day, after all the time, it's still just going to be hydrogen gas, ready to go. It doesn't change. And I thought that was really badass.
It's got an excellent point, too.
Yeah, it's just a shame that it's not entirely off grid. I mean, I suppose he could do solar panels, but solar panels also degrade over time, I've heard. What do they last, like 20 years maximum? And they get worse and worse over time.
Yeah, PV plates are temporary. Or photovoltaic plates, excuse me. Yeah, they're temporary, man.
Have you heard of drinking birds, Jeremy?
Woodpecker, perhaps.
It does seem just pretty obvious, though. I'm not saying solar panels are the way. I'm not even saying drinking birds are the way, but there's just so much energy around us in nature of things that we can tap into, and people used to with those water wheels and stuff. Now I know that you can't put a million water wheels on the same river. I get it, but still, just shouldn't as much energy as we use come from just tapping into nature? just they're just the flow of chi, as the Chinese would call it, right? Just tap into the movement that is unstoppable all around us. And
Well,
I mean, there's just so much energy. It's crazy that we need to like dig shit out of the ground, burn it, refine it, and then combust it.
there's a lot of stuff that was demonstrated and then it's been dismissed since then, right? Written off, whatever. It's nuts. Like from Nathaniel Stubblefield's work to John Keeley to I can't recall his name, but he put on a demonstration of so-called over unity himself, and they're making this over unity sound like something complex and unobtainable, but we're experiencing it all the time.
You think? Over unity? Oh, that's a bold claim, my friend.
Ain't it?
It sure is. Who
Yep.
who the hell is doing over unity?
We are.
What with plutonium or something?
No,
What?
no, fuck no. The individual, the what's going on within us,
Oh, you're talking
the
about like my own
energy.
human body?
Yeah, the electrical system, the myelin sheath, the fascia, the not to mention the symbiosis, and yeah, but that leads into other subjects of how it's been used
Well,
against
I don't know
us.
if that's over unity, but I will give credit to biology as being basically the most advanced technology that exists in the world, and that maybe maybe the ceiling that we could ever strive to match is making machines as efficient as, our own bodies themselves. That might be the ultimate goal, just to make, you know, uh, non-conscious machines operate on the same, minute level of chemical interactions that an animal body does. Because I mean, I'm sure you've heard of the comparison of like how many computations can your brain do with literally all it needs is to eat a couple peanuts as its fuel, eat a banana, and that can fuel how many computations in your mind, compared
Yeah.
to a computer that needs all these different energy resources.
Yep,
It's like,
and going back to the word calorie in its original true meaning, literally, one
right.
nutritional calorie is 1/1000th of one electrical calorie, mechanical electrical SI unit. To this day,
Yeah, that's
to this
that. I
day,
have this. I have this crazy idea that if man makes robotic AI, right, sort of like conscious life form, and then it, makes something better than itself, and then it makes something better than itself, what eventually is going to happen is that, biology creates these robotic life forms, and then as it improves itself, it ends up uh, creating basically a biological organism at the end of the day. Not that it'd be exactly like our current human bodies, but that it might just get passed back and forth between like biological life forms that think that the path towards improvement is like robotics, and then the robotics improve to the point where they turn themselves into flesh and blood. Metal to flesh, flesh to metal, back and forth, perhaps.
well, I'm quite familiar with some experiments that were successfully performed back when I was at UF. There was a guy. He grafted rat brain neurons to processors and used them to pilot F-22s. That's been a while back, so I'm sure the tech has come way, way further since then. That's been a while back. But I think, yeah, I'm pretty sure that's public knowledge now.
Do you think AI robot God is coming our way in our lifetimes?
Dude, I don't even know what the hell that is. I don't claim to know uh, things like that. I don't know. But do
Well,
I think? Like, do I
there's
think?
primitive AI at this point, right? Which is
Yeah.
like algorithmically driven. And the next step past that is AGI, artificial general
General.
intelligence, where
Gotcha.
it's like basically human level AGI. Well, not human level in the sense of like a freeze frame, but it can obviously work faster than us theoretically. So, AGI is like 100, or more like a trillion humans working on the same project in tandem, sharing notes with each other, but all in one computer. And then past AGI is ASI, artificial super intelligence, and that's when most people would probably like bow down and be like, "Oh wow, we created AGI. AGI then evolved itself into artificial super intelligence, and that's when all of us peons bow down to our new digital god."
I think, yeah, if there's enough useful idiots, willing, yeah, that's a possibility. But yeah, then that'll mean that a bunch of us just won't be around for it because
You heard
we
of the
won't.
Turing test?
That sounds familiar.
The Turing test. I'm pretty sure that's named after some guy's last name who came up with this concept. But they were talking about it back in the day, like, when will we know when a computer has achieved AGI? Now, our standards, since his Turing test was originally designed, they've evolved because what's happened is that the Turing test has already been passed by our current AI. And by the old school standards, we have invented AGI, but we've kind of, what's the expression? Move the
Move
goalposts
the
of
goalpost.
AGI?
Yeah. Yep.
Yeah.
No, the Turing test, first of all, Turing wasn't just some guy. He basically invented computers, okay? And second of all, the Turing test was to see when you couldn't tell if you were talking to a robot or not.
Well, that
It
that
didn't have
was
to
the
do with AGI or whatever.
well the way I remember it is that when you couldn't tell if separated by a wall if the person you were talking to was a computer or an actual human being, that is the Turing test to determine when we've achieved AGI, whether you could tell or not. But I could be wrong.
No, it was
B-
just to see when you couldn't tell if you were talking to a computer or not. That's all.
Kind of like
Okay.
with the
Well,
graphics in the fourth wall, correct?
It didn't have to do with
make
AGI or anything like that.
makes
Well, it did
makes
have to
sense
do when
to
it exhibited intelligence, though.
maybe I got that mixed up, but it does make sense to me that some people would say, "Hey, if I can't tell whether it's a human or a robot behind the wall that I'm talking to, that means that robot can emulate perfectly human presentation, which is the standard of AGI, if you're at human level or not." So either way, you might be right, but point made. Anything the point. I mean, what is AGI if not that then?
What is AGI?
What is AGI if not I can't tell if it's a human or a robot I'm dealing with?
Well, we already have the can't tell part. You know what I'm saying? They passed the Turing test a long time ago. The
Right.
AGI thing is when the computer basically becomes sentient. That's a whole different like.
I don't
That
know if
was
that's the case, but I definitely think if what I'm saying is true, then, or maybe it's not true, but if it is, the goalposts have been moved where it's like, all right, it passed the Turing test, but by today's considerations, we haven't made AGI, although we have passed the Turing test, which is still quite a milestone to have passed. Because ChatGPT like 3.0 or whatever, we're on like 6 or something now. I don't know, but like 3 passed the Turing test like 4 years back or something.
So I'm saying we don't have AGI, but we've passed the Turing test. So it's like not this. It's different. It's the Turing test is when it can trick you into thinking it's a conscious being with, you know what I'm saying? You can't tell you're not talking to another human. That's all it is. Like the AGI, we don't even have yet.